Hi guys, welcome to my channel. In this video, I will be covering complete Unit 3 in Computer Network subject. I will explain each and every topic in detail, and whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. Guys, I will provide complete Unit 3 handwritten notes in description. You can download from description. I will explain what is network layer, functions and design issues of network layer, what is packet switching network and what is virtual circuit network, what are various routing algorithms and their classification, what is optimality principle, what is link state routing algorithm, Bellman-Ford algorithm, what is hierarchical routing, flooding, what are broadcast routing algorithms, what is conjunction control, types and applications of conjunction control, what is difference between flow control and conjunction control, what are various congestion control approaches, what is internetworking, what is fragmentation quality of services, what is tunneling, what is ICMP, DHCP, what is IP addressing and IP address classes, what is subnetting, and what is CIDR, that is classless interdomain routing. And also I'll explain what is IP protocol, IPv4, IPv6, header format of IPv4 and IPv6, and difference between IPv4 and IPv6, what are various multicast routing algorithms, applications and types, what is ARP, that is address resolution protocol, what is multiprotocol label switching, what is hierarchical switching, what is OSPF, BGP, IGMP, and what is mobile IP. I will explain each and every topic in detail. Guys, I have uploaded complete computer network subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first I will explain what is network layer, and then I will explain functions and design issues of network layer. Guys, OSI model contains 7 layers and the network layer is third layer. So network layer is the third layer in the OSI model. It is responsible for routing, forwarding, addressing and delivering data packets between different networks. Guys, I will explain in detail about what is routing, forwarding, addressing and delivering data packets. And the network layer ensures that data is transmitted from source to destination even if they are located in different networks. Just for example, one company is in Hyderabad and next company is in UK. Company in Hyderabad is one network and company in UK is other network. Even though if companies are in different networks, companies can communicate each other by using network layer. Next I will explain functions of network layer. Guys, network layer contains different types of functions. By following all these functions, all devices can communicate each other even though if devices are located in different networks. First function is logical addressing. We also call logical addressing as IP addressing. So first function is addressing. Every device on a network has a unique identifier called IP address, where IP stands for Internet Protocol. The network layer assigns these IP addresses to source and destination devices so that data reaches the correct location. Yes, for example, if you consider devices like laptops, iPads, tablets, mobiles and computers, if any devices are connected to network, then network layer will give one number to the devices. We call that number as IP address, where IP stands for Internet Protocol address. If one computer wants to send data to other computer in network, then data can be transferred by using this IP address. Yes, for example, this computer wants to transfer data to this computer. So this computer will identify this computer based on IP address. Second function is routing. Thus, if one computer wants to send data to other computer, network layer will find the best route in order to send data. If network layer finds the best route, then data will be transferred from sender to receiver very fast. So process of selecting the best path for data transmission is called routing. Network layer will find the best path, so data will be transferred from sender to receiver very fast. And in order to find the best path, network layer will use various kinds of routing algorithms such as shortest path routing, distance vector routing, and link state routing. By using these routing algorithms, network layer will find the best path from sender to receiver in network. And third function is forwarding. Once the best route is selected, the data packets are forwarded from one device to other device until they are reached at a final destination. Guys, devices mean routers. Data will be transferred to various routers until data is successfully reached to receiver. Guys, each and every router contains table. In the table, all other router informations are stored. So router will find the best route by seeing the table. So forwarding means transferring data from one router to other router until data is successfully reached to receiver, and router will identify best route by seeing table. And fourth function is packetizing and fragmentation. Network layer will perform packetizing. That is nothing but dividing our complete data into pieces. We call these pieces as packets. Yes, for example, if packet is too large, then further again our packet is divided into pieces. So dividing our larger packet into smaller parts is known as fragmentation. So network layer will perform both packetization and as well as fragmentation. Each packet is transferred to receiver. Whenever receiver receives data, how sender transfer data, in same way, again data is rearranged in order and then receiver will read the data. And fifth function is error handling and congestion control. Because if there are any errors in packets, the network layer will identify that error and as well as network layer will correct that error. This is meaning of error handling. Because congestion means too much traffic in network. For example, if you consider road, if so many vehicles are passing in single road, then there will be traffic jam. In same way, if multiple devices transfer data at the same time in network, then there will be traffic jam. So network congestion means too much data traffic in a network. Because if there is too much traffic in network, then data will be transferred to receiver very slow. There is also chance for loss of packet. If there is too much traffic, some packets will be lost and they are not reached to receiver. And last function is quality of services. Shortly we call it as QoS. Because if multiple devices transfer data at the same time in network, then there will be congestion. That is nothing but traffic jam. For example, let us say one person is sending email and next person is doing video call. So if there is high traffic in network, then critical applications like video calls and online gamings, these both are given high priority when compared to emails. If there is high traffic, the network gives permission to video call and network will not allow emails. So critical applications like video calls and online gamings, these both are given high priority when compared to emails in order to control congestion in case if there is high traffic. These are various functions of network layer. Next I will explain design issues of network layer. Because network layer has several design issues. So network layer need to identify these issues and network layer need to correct these issues. So devices can communicate each other in network efficiently. First design issue is IP address management. In network, each and every device is given one unique number. We call that unique number as IP address. Because normally in network, there are two types of addresses. One is IP address and next one is MAC address. One device will identify to other device by using these addresses. So network layer will assign IP address for each and every device. But problem is, in network, there are billions of devices. So assigning IP address for each and every device is very tough. Network layer need to manage that. It is challenging part. And second one is routing strategy. If one computer want to send data to other computer in network, the network layer will identify best path. By using that best path, data will be transferred from sender to receiver. So duty of network layer is to identify best path from source to destination. Routings are classified into two types. One is static routing and next one is dynamic routing. In static routing, network administrator will set route manually. Even if best path is available, this route will not change. For example, this computer wants to send data to this computer. So network administrator will set one path. For example, this is path through which data will be transferred. Only by using this path, these two devices need to communicate. Even though if best route is available, still this device need to communicate only by using this path. So in static routing, at first a path is set between devices and then by using this path, device will communicate. And whereas in dynamic routing changes the route automatically based on network condition. As for example, in dynamic routing, this computer wants to send data to this computer. So at first, device will transfer data by using this route. But this device will identify that this route has heavy traffic. So simply, instead of taking this route, device will communicate by using this route. So in dynamic routing, device will automatically change routes based on network condition. Sometimes in network, traffic is very high and sometimes traffic is very low. Network condition is changing frequently. In that situations, finding best path is complicated. If network layer takes too much time to find best path, then data transfer will be late. So network layer need to find best path very fast. So data will be transferred very fast. This is challenging part. And third one is packet loss and error handling. Because if there is any congestion in network, that is nothing but if there is too much traffic in network, sometimes receiver may receive wrong data. If receiver receive wrong data, then network layer need to identify that error and network layer need to correct that error. And also in some situations, complete data will be lost due to high traffic. In case if there is any data loss, network layer must find that lost data and then network layer need to resend the data again. So identifying lost data and then sending that same data again is challenging part. And fourth challenge is fragmentation and reassemble. Guys, whenever one computer wants to send data packet to other computer, if that packet is very large, then further that packet is divided into various parts. We call that part as fragments. After all fragments reach the destination router, how sender transfer data? In same way, all fragments need to reassemble in order so that receiver will read the data. But in this challenging part is, even though if there is any single fragment loss, all fragments need to be retransmitted again, which will cause delays. That is nothing but receiver may receive data very slow. Network layer need to rearrange the data in order so that receiver reads the data. And fifth challenge is congestion control. That's in network. If multiple devices are sending data at the same time, then there will be too much traffic. If there is too much traffic in network, then data will be transferred to receiver very slow or sometimes network blocks. So congestion control can be done by using two ways. First one is packet queuing and second one is traffic prioritization. For example, whenever traffic is very high, router will not send data immediately to receiver. Instead, router takes data from sender and then router will wait some time until traffic reduces. Only after reducing traffic, router will transfer data. This is meaning of packet queuing. And whereas traffic prioritization means, in case if there is too much data in network, allowing only important data to send first and making unnecessary data to wait. It is known as traffic prioritization. Network layer will allow only important data and network layer makes unnecessary data to wait. This is meaning of traffic prioritization. But in this challenging part is, if high traffic is not controlled properly, then data will be transferred to receiver very slow and sometimes packets may lose. And even in some situations, network may failure. So by using two techniques, network layer must control congestion and network layer need to allow only important data to send first by making unnecessary data to wait. And last challenge is security concerns. Billions of people will use network in order to transfer data. Guys, in network, hackers may hack our data. So in order to protect our data, there are two solutions. First one is encryption and second one is firewalls. Yes, encryption is nothing but converting our message into unreadable format is known as encryption. For example, whenever sender wants to transfer any important data, then sender will convert the data into unreadable format. So even though if a hacker hack our data, he cannot understand the data because the data is in unreadable format. So whenever receiver receives encrypted data, then receiver converts the data into readable format. This is meaning of encryption. And second one is firewalls. Guys, in our systems, we need to turn on firewalls. Firewalls will block unauthorized data, so which will protect our data from hackers. But in this challenging part is, encrypting each and every data packet is time-taking process, which will slow the network. And next challenging part is, sometimes instead of blocking unnecessary data, firewalls may block important data, which will cause problem. All these are challenges of network layer. Next I will explain what is packet switching. We also call it as packet switching network, and then I will explain types of packet switching. I will explain connectionless packet switching and connection oriented packet switching. We also call connectionless packet switching as datagram network, and we also call connection oriented packet switching as virtual circuit. Whenever one computer wants to send data to other computer in network, complete data is not transferred at a time. Instead, complete data is divided into smaller pieces. We call it as packets, and each packet will find the best route in order to reach to destination. So in packet switching, instead of sending complete data at a time, complete data is divided into packets and then each packet is transferred to receiver. So packet switching is a method of sending data in a network by breaking data into smaller packets and transmitting them individually. These packets travel separately and may take different routes to reach to destination, where they are reassembled into the original data. Each packet will take different routes in order to reach to destination. After reaching to destination, all packets will reassemble in order, like how are you. So receiver will read how are you. This is structure of packet switching network. As for example, let us say this is one company and this is other company. Host is nothing but computer which can send data and as well as which can receive data is known as host. For example, let us say this computer want to send data to this computer. Whenever this computer send data, this data is traveled through different routers and then data is reached to destination. As round circle symbols, we consider it as routers. All these routers in different locations are connected by using communication lines. Communication lines are nothing but cable wires. All these routers are connected by using cables. So whenever this computer sends data through various routers, data is reached to this computer. Guess routers and as well as communication lines. We call this both combination as subnet. So subnet is the collection of routers and communication lines. This is structure of packet switching. This is how packet switching will work. And the first one is data is broken into packets. Yes, for example, if there is any large data, that large data is broken into various packets. And second step is packet travel independently. After large data is divided into smaller packets, each packet will travel independently by using different routes. And third step is packet reaches the destination. By using various routes, all packets will reach to destination. After reaching to destination router, again data will be arranged in order. So receiver will read correct message. These are advantages of packet switching and the first one is efficient. Thus multiple packets will travel at the same time using different routes. So data will be traveled very fast. This is meaning of efficient. And second one is fault tolerance. If one route fails, packet can use alternative routes. Yes, for example, data is traveling by using this route. If this route fails, then data travels by using this route. So data can be traveled by using various routes. So even though if one single path fails, data will be traveled by using other paths. These are disadvantages of packet switching network. And the first one is packet may arrive out of order. Yes, whenever sender sends data like how are you, this complete data is not reached in order. Data will be reached to receiver router like are, you and how. So there is no proper order. As each packet takes different routes, data will be not reached in order. But whenever data is reached to receiver router, this receiver router will arrange data in order like how are you. So receiver will read correct message. Data after reaching to destination router need to reassemble the data in order. And second one is possible delays. As for example, if multiple people are sending data at the same time in network, then there will be high traffic. In case if there is any high traffic, packets will reach to receiver very slow. These are disadvantages of packet switching. Guys, there are two types of packet switching. One is connectionless packet switching and second one is connection oriented packet switching. Let first of all explain what is connectionless packet switching. Guys, we also call connectionless packet switching as datagram network. Guys, datagram and data packet. Previous example which I explained, that is example of datagram network where complete data is divided into packets and each packet will take best route in order to reach to destination. So in this method, packets are sent individually and each packet takes its own path to the destination. Packets will travel by using different routes based on network condition. For example, if there is any high traffic, then data will take other path, and if there is any path failure, then data will use other path. And for example, if there is any shortest distance available, then data will be traveled by using the shortest path. So based on network conditions, packets will travel by using various paths. So in datagram network, there is no fixed path. Routes will be changed based on network condition. And in this datagram network, as each packet will take different route, data will not be reached in order. So only after data reaching to destination router need to rearrange the data in order. This is diagram of datagram network. For example, this is source computer and this is destination computer. And this network layer will divide our data into packets. Complete data is divided into two packets. This packet will take best route in order to reach to destination. And similarly, this packet will take best route in order to reach to destination. So two packets will take different routes. And after reaching to destination router, packets will be rearranged in order. So in receiver side, network layer will rearrange data in order. This is example. For example, if we consider internet, whenever we transfer data in internet, our complete data is divided into packets and each packet will take different routes. And then after reaching to destination, data will reassemble in order. These are advantages of connectionless packet switching, that is advantages of datagram network. And the first one is packets will take best available route. Each packet will select the best route in order to reach to destination. So data will be reached to receiver very fast. And second one is, if one route fails, packets can take other route. For example, if this route fails, then packet will take this route. And third one is suitable for larger networks like internet. Guys, we'll use datagram network in big networks like internet. These are disadvantages. And the first one is packets may arrange out of order, requires reassemble. In datagram network, data is not sent in order. Only after data reaching to destination, then destination router rearrange data in order. And second disadvantage is no guarantee, as packets may be lost in transmission. As if network condition is not good, like if there is any congestion, that is high traffic or line failure, then some packets may be lost. So even though if there is any single packet loss, sender need to send all packets again. So there is no guarantee that all packets will be reached to receiver, as some packets may be lost in transmission. Next packet switching is connection oriented packet switching. We also call it as virtual circuit network. Guys, we also call virtual circuit as virtual path. In this method, a fixed path, we call that fixed path as virtual circuit, is established before data transmission begins. All packets follow the same route, ensuring they arrive in order at the destination. The connection is maintained until all packets are transmitted and then connection is closed. This is example. Yes, for example, this computer wants to send data to this computer. So, before transmitting data, at first connection is established between these computers. Even the best route is available, still data will be traveled by using this path. And that too, data will be traveled in order. For example, sender will send data like how are you. So how is sent first, and then R, and then you. So complete data is traveled in order. So receiver will receive data in order, like how are you. After sender successfully transferring data to receiver, connection will be closed. MPLS, that is Multiprotocol Label Switching. This is example of virtual circuit. This protocol is example of virtual circuit, and this protocol is used in businesses and as well as telecom companies in order to transfer data very fast and securely. These are various phases in virtual circuit packet switching. First one is VC setup phase, where VC stands for virtual circuit. Virtual circuit is nothing but a fixed path is established between sender and receiver before transferring data. Only by using this path, data will be traveled. And second phase is data transmission phase. In data transmission phase, all packets are transferred to receiver in order. In datagram network, data will not be traveled in order. But whereas in virtual circuit, all packets will follow same order. Like how sender transfer data, in same way, receiver receives data. And third phase is VC termination phase. Once complete data is sent to receiver, connection will be closed. These are advantages of virtual circuit. And the first one is packets arrive in order, so no reassembly is needed. A second advantage is reliable communication. As before transferring data, the first connection is established, so there will not be any loss of data. And third one is fast transmission. As connection is pre-established, data will be traveled very fast. These are disadvantages. And the first one is if a router fails, then we need to re-establish entire connection. As for example, this is fixed path, but this router is not working. So again, network layer must create new connection. Second disadvantage is delay. As before transferring data, at first connection need to be established. So it will take time. So there is delay in data transfer. These are differences between datagram network and virtual circuit network. Whereas in datagram network, each packet will take different routes. And whereas in virtual circuit network, all packets will follow same path. So here data will not reach in order. And whereas in virtual circuit network, data reaches in order. In datagram network, we are not establishing connection at first. As we are not establishing connection at first, there may be chance for packet loss. And whereas in virtual circuit network, before transferring data, at first connection is established. So there is no loss of data. Internet communication is example of datagram network. And whereas MPLS and ATM networks, these both are examples of virtual circuit network. As in exam, you may get question like explain differences between datagram network and virtual circuit network. Or they may also ask like explain connectionless service and connection oriented service. So you need to explain this complete answer. Next I will explain what are routing algorithms, and then I will explain classification of routing algorithms. I will explain what are adaptive routing algorithms. We also call it as dynamic routing, and what are non-adaptive routing algorithms. We also call it as static routing. And then I will explain what is optimality principle. Whenever one computer wants to send data to other computer in network, if there are so many routes available in network, then routing algorithms will find the best route, that is nothing but shortest path, in order to send data. So data will be traveled very fast. So routing algorithms find the best path for data packets to travel from source to destination in a network. Routing algorithms help the network work faster and better. Routing algorithms are classified into two types. At first I will explain what are adaptive routing algorithms. We also call it as dynamic routing. Guys, in dynamic routing, dynamic means routes will change frequently based on network condition. There will not be any fixed route in order to transfer data. So routes will change frequently based on network condition. For example, this is network. In this network, all routers are connected to each other by using links. Links are nothing but cables. Routers are connected to each other by using cables. And this computer wants to transfer data to this computer by using this route. But in this route, so many other devices are transferring data in this route. So traffic is very high. As traffic is very high in this route, so instead of transferring data in this route, immediately this computer will send data by using this route. So instead of this route, this computer will use this route. But again in this route, there is cable break. For example, this link is not working due to cable failure. As cable is not working in this route, immediately this computer will shift other route. So data will be transferred by using this route. So in dynamic routing, routes will change frequently based on network condition. Network condition can be either high traffic or link failure, or if any shortest path is available, data will be traveled by using that path. So adaptive routing algorithms update the routing path dynamically, that is nothing but automatically, based on network conditions such as high traffic and link failures. So in adaptive routing algorithms, routing paths are updated automatically based on network conditions such as high traffic or link failure. The algorithm keep on checking the network condition and update the list of paths in the router. So data will be traveling best way. Guys, in dynamic routing, routing algorithms will find best path in order to transfer data, and each and every path information is stored in router. So in dynamic routing, routers contain each and every information about paths, like what are various routes available. So in dynamic routing, complete information about paths are stored in router. So router will choose best path in order to send data. These are examples of adaptive routing algorithms. They are distance vector routing, link state routing, open shortest path first, shortly we call it as OSPF, and BGP, that is Border Gateway Protocol. All these are examples of adaptive routing algorithms, that is dynamic routing. These are advantages of adaptive routing algorithms. And the first one is adapts to network changes. Guys, name adaptive routing algorithm. That is nothing but these algorithms can adapt to network changes. Like if there is any high traffic or network failure, immediately device will shift to other path in order to send data. And this dynamic routing will provide better performance. If network is busy, that is nothing but so many devices are using network, or if there is any unpredictable network, in that situations dynamic routing is suitable. In dynamic routing, each and every router need to store complete information about various links, like what are various routes available in order to send data, and also each router need to identify best path in order to send data. So in dynamic routing, processing power and memory is required. As router need to identify network condition frequently, extra time is required for router in order to identify network condition. These are disadvantages of dynamic routing. There are three types of adaptive routing, and the first one is centralized routing. Guys, in centralized routing, there will be central node. The central node can be either router or server. Only the central router gathers network information and then makes routing decisions. And second one is distributed routing. Guys, in distributed routing, each and every router contains information about other routers, and each and every router makes decisions independently. And whereas third one is isolated routing. Guys, in isolated routing, routers will take decisions without consulting other routers. Whatever the local information available in that router, only by using that information, particular router will take decisions without consulting other routers. This is meaning of isolated routing. And second one is non-adaptive routing algorithms. We also call it as static routing. Because in static routing, there will be predefined path. Only by using this path, data will be traveled from one computer to other computer. And this path will not change based on network conditions. For example, this computer wants to send data to this computer. For example, this path is fixed not to send data. Before transferring data between these computers, at first a path is selected. For example, these two computers want to communicate by using this path. So at first this path is fixed. Only by using this path, these computers need to communicate each other. Even though if there is high traffic or any link failure, so even though if network condition is changing frequently, still these computers need to communicate only by using this path, as this path is fixed. And there is one person called network administrator. Network administrator will set this path in order to transfer data. Shortest path algorithms like Dijkstra's algorithm and flooding and fixed routing. All these are examples of static routing. These are advantages of static routing. As when compared to dynamic routing, static routing is very easy to implement as route is already fixed in order to transfer data. So there is no need for routing calculations. So there is no need to find route. These are disadvantages of static routing. And the first one is static routing will not change based on network condition. For example, this link is not working. So data will not be transferred to receiver because this link cannot be changed based on network conditions. Shifting to other route is not possible in static routing. So static routing is not efficient when compared to dynamic routing. We also call static routing as non-adaptive routing. There are three types of non-adaptive routings. And the first one is flooding. As in flooding, each data packet is transferred to all connected routers. For example, this computer wants to send data to this computer. So this data packet is transferred to all these connected routers. So data packet is transferred to this router and this router. Similarly, these routers will transfer data to its connected routers. Similarly, data will be transferred to these routers and these routers. So data will be keep on flooding until data is successfully reached to receiver. And second one is random routing. Guys, in random routing, some routes are selected and data will be transferred only by using that routes. For example, this route is selected and similarly this route is selected. So data packets will be transferred to this route and this route until data is successfully reached to receiver. And this path is not selected, so data will be not transferred to this path. And whereas third one is shortest path routing. That's Dijkstra's algorithm. This is one of the example of shortest path routing. In next class, I will explain what is Dijkstra's algorithm in detail. Next, I will explain what is the optimality principle. Guys, optimality means best choice. The optimality principle states that the best route between 2 points in a network can be found without knowing the entire network structure or traffic condition. Guys, I will give an example so that you can clearly understand what is optimality principle. Guys, for example, there is best route from my village to Goa. In order to travel to Goa, at first from my village, I need to go to Hyderabad, and from Hyderabad, I need to go to Bangalore, and from Bangalore, I need to go to Goa. So if there is best route from my village to Goa, then there will be best route from my village to Hyderabad, and Hyderabad to Bangalore, and from Bangalore to Goa. So optimality principle says that if there is best route from source to destination, then all remaining routes also considered as best routes. So from my village to Hyderabad is best route, Hyderabad to Bangalore is best route, and similarly Bangalore to Goa is best route. So all remaining routes are best routes. So optimality principle says that if there is shortest route from router X to router Z, then the path from router Y to router Z is also a best route. For example, this is router X and this is router Z. So if there is optimal path from router X to router Z, then there will be optimal path from router X to router Y, and there will be optimal path from router Y to router Z. So optimality principle states that if there is shortest route between 2 points, then all remaining routes which are connected to the 2 points are also best routes. These are advantages of optimality principle. And the first one is optimality principle will find shortest path easily. So routers need not to perform any routing calculations. This optimality principle is used in many routing algorithms. First disadvantage is optimality principle cannot identify high traffic and it cannot handle link failures. And this optimality principle is not suitable in dynamic routing. For example, link from X to Y is not working. So data cannot be transferred to receiver. And similarly, even though if there is best path from router X to router Z, if there is any high traffic from router Y to router Z, then data will be reached to receiver very slow. So optimality principle cannot handle high traffic and as well as link failures. And it is not suitable in dynamic routing when network conditions are changing frequently. And this optimality principle will help Dijkstra's algorithm and as well as Bellman-Ford algorithm in order to identify best path from sender to receiver in a network. Next, I will explain what is link state routing algorithm. The link state routing algorithm is a dynamic routing algorithm. That's dynamic routing algorithm means Whenever sender want to transfer data packet to receiver, there will not be any fixed path to transfer data. Routes will keep on changing based on network condition. So link state routing algorithm is a dynamic routing algorithm. That means routes will keep on changing based on network condition. This link state routing algorithm will find best route in order to transfer data from sender to receiver. In link state routing algorithm, each and every router contains information about all other routers in the network. For example, if you consider this router contains information about each and every router connected in the network. And these routers also contain information about various routes available in the network. So routers can easily calculate and find the shortest distance. So the link state routing algorithm is a dynamic routing algorithm that finds the best path for data packets in a network. Each and every router follow link state protocol. So link state protocol works by collecting information about all routers and connections. After collecting information about all routers and connections, each router then calculates the shortest distance in order to transfer data. This is how link state routing algorithm will work. Guys, for example, this is a network. In this network, all these are routers and each router is connected to other router with some distance. And second step is, each and every router will send message to all the routers connected to it. This router 1 is connected to router 2 and router 3. So router 1 will send message to router 2 and as well as router 3 in order to collect information about router 2 and router 3. As router 1 will send message to router 2 and as well as router 3 in order to collect information, and we call that message as link state packet message. Shortly we call it as LSP, where LSP stands for link state packet message. Distance from router 1 to router 2 is 2. Similarly, distance from router 1 to router 3 is 5. So now router 1 will store information in routing table, and similarly, now router 2 will send LSP message to all the routers connected to it, as router 2 is connected to router 4 and as well as router 3. So now router 2 will send LSP message to router 4 and as well as router 3 in order to collect information. Now router 2 will store that information in routing table. Next to router 3 is connected to router 5 with a distance 3, and similarly router 4 connected to router 6 with a distance 1, and similarly router 5 is connected to router 4 and as well as router 6 with a distance 2 and 5, and last router is router 6. As router 6 is last router, it is not connected to any other routers. Now each and every router knows how other routers are connected. So each router will send LSP message to other routers which are connected to it in order to gather information about other routers. After gathering information about each and every router, all routers will store that information in routing table. Now, source router will use Dijkstra's algorithm in order to find shortest path from source node to all other nodes. For example, let us say this router 1 is source node. Now, Dijkstra's algorithm will find shortest path from source node to each and every node. Now I will explain what is Dijkstra's algorithm. Shortest path problems are classified into two types. One is single source shortest path problem and next one is all pair shortest path problem. Example of this single source shortest path problem is Dijkstra's algorithm. In single source shortest path problem, initially we need to select one single node as source node. From that source node, we need to find the shortest distance for all other nodes. I will give one example so that you can clearly understand Dijkstra algorithm. Single source shortest path problem. Single source means we need to select one source node, single node. So I am selecting this node 1 as source node. Now initially mark all other nodes as infinity. That means we did not visit all these nodes. So I am marking this node's value as infinity. Now from node 1 to node 2, distance is 2. So replace this infinity with 2. I visited this node 2. Similarly, from node 2 to node 3, distance is 4. So we need to replace this infinity with 2 plus 4. That is 6. And similarly, distance from node 3 to node 4 is 6 plus 6. That is 12. So I am replacing this infinity with 12. Now I visited this node 2, node 3, node 4. I visited all the nodes. So distance from node 1 to node 2 is 2 and distance from node 1 to node 3 is 6 and distance from node 1 to node 4 is 12. Now we visited all other nodes. This is single source shortest path problem. Worst case time complexity of Dijkstra algorithm is theta of n square. I will give one example. Initially in step 1, I am selecting one source node. For example, I am selecting source node as this node 1. This node 1 is source node. Now we need to mark all other nodes as infinity because we did not find shortest distance. So I am marking this distance for all other nodes as infinity, infinity and infinity. Meaning of infinity is unvisited. I selected this node 1 as source node. This source node is directly connected to node 2 and node 3. So distance from node 1 to node 2 is 2. So I am replacing this infinity as 2. And similarly, distance from this node 1 to node 3 is 5. So I am replacing this infinity with 5. This node 2 is connected to node 3 and node 4. So distance from node 2 to node 4 is 2 plus 8, that is 10. So I am replacing this infinity with 10. I visited this node 4. I already visited this node 3. Value of this node 3 is 5 because from 1 to 3 distance is 5. So I given this value of 3 is 5. But distance from node 2 to node 3 is 2 plus 1, that is 3. 3 is smaller than 5. So I am replacing this 5 with 3. Now node 3 is connected to 5. So distance from 3 to 5 is, distance of this 5 is 3 plus 3, that is 6. So I am replacing this infinity with 6. I already visited this node 4. Distance of this node 4 is 10. But node 5 is connected to node 4 and node 6. So distance from this node 5 to node 4 is 6 plus 2, that is 8. So 8 is smaller than 10. So I am replacing this 10 with 8. And similarly, distance from this 5 to 6 is 6 plus 5, that is 11. So I am replacing this infinity with 11. But from this node 4 to node 6, distance is 8 plus 1, that is 9. 9 is smaller than 11. So I am replacing this 11 with 9. Now we visited all the nodes. This is shortest distance from node 1 to all other nodes. Now we need to write table for this. Distance from node 1 to node 2 is 2. So here we need to write 2. And similarly, distance from node 1 to node 3 is 3. And distance from node 1 to node 4 is 8. And distance from node 1 to node 5 is 6. And distance from node 1 to node 6 is 9. We selected one single source node as node 1 and we found shortest distance to all other nodes. This is single source shortest path problem. Guys, you may get doubt like from node 2 to node 4 distance is 8. But why we are counting this value? Because we are finding shortest distance from node 1 to node 4. So that we need to count both this 2 and 8. Guys, in exam don't write like this. Write this graph in step by step manner. Like this you need to write. For each visit you need to write one graph. This is an algorithm. Initially step 1 is start. After that in step 2 we need to select one source node. After selecting source node in step 3 we need to assign all other node values as infinity except that source node. And in step 4 we need to find shortest path from this source node to all other nodes. Once we found shortest path to all other nodes, step 5 is stop. This is algorithm. There is one disadvantage of this Dijkstra algorithm, that is visited node is never checked again. That means once we visit that node, once we perform relaxation, we should not check that node again. This is disadvantage. Guys, in exam you may also get separate question like explain Dijkstra's algorithm with an example. Without drawing all these tables, directly you can write that example. Now these are shortest routes from source node to all other nodes. After calculating shortest route from source node to all other nodes, now complete information is stored in routing table. For example, this router 1 contains this routing table. So from router 1 to 2, there is direct link where distance is 2. And similarly from 1 to 3, shortest distance is from 1 to 2 and from 1 to 3. So where distance is 3. And similarly from 1 to 4, shortest route is, so from 1 to 2, 2 to 3, and from 3 to 5, and from 5 to 4. Total distance is 8. 8 is shortest distance. Similarly from 1 to 5, shortest distance is 1 to 2, 2 to 3, and 3 to 5. Where shortest distance is 6. And similarly from 1 to 6, shortest distance is 1 to 2, 2 to 3, 3 to 5, and 5 to 4, and 4 to 6. Now we got a shortest route from source node to each and every node. Guys, we selected router 1 as source node. For example, if you consider source node as router 2 contains information about all other routers. Now routers can easily forward data to other routers by using the table. Guys, this is how link state routing algorithm will work. Each and every router will find neighbors which are connected to it, and also they measure cost. Cost is nothing but with how much distance that routers are connected. And whereas step 2 is each and every router will send message to all other routers which are connected to it, and we call that message as link state packet message. After sending link state packet message, each and every router will get information about all other routers. After getting information about all other routers, each router will store that information in table. Now, each router knows about all other routers which are connected to it. Each and every router will use Dijkstra's algorithm in order to identify shortest path from source router to all other routers in the network. After applying Dijkstra's algorithm, each router will maintain routing table. Now, each router will easily forward data to other routers. This is how link state routing algorithm works. These are advantages of link state routing algorithm. Link state routing algorithm will find best path quickly. And if there is any cable break, then link state routing algorithm will find other path quickly. These are disadvantages. Each and every router must maintain table. So routers must store and process lot of information, which will take time. And when compared to simple routing methods, this link state routing algorithm is complex. Guys, whenever link state routing algorithm comes in exam, you need to explain this example, table. After drawing table, you need to explain Dijkstra's algorithm. After applying Dijkstra's algorithm, we need to store complete information in routing table. Next, I will explain what is Bellman-Ford algorithm. Guys, Bellman-Ford algorithm is also used to find shortest path from source node to all other nodes in a network. And this algorithm is mainly used in distance vector routing protocols. Whereas if you consider Dijkstra's algorithm cannot handle negative edges. But whereas Bellman-Ford algorithm can handle negative edges. But when compared to Dijkstra's algorithm, Bellman-Ford algorithm is slow. And this algorithm is based on RIP protocol, where RIP stands for Routing Information Protocol. Initially, this algorithm will find better routes, and again updates are done even if better routes are found later. These are advantages of Bellman-Ford algorithm. When compared to Dijkstra's algorithm, Bellman-Ford algorithm will work for negative edges, and it is very simple and easy to implement. And this algorithm is based on Router Information Protocol. These are disadvantages. Applying Bellman-Ford algorithm for large networks is very slow. And if any negative edges form cycle, then Bellman-Ford algorithm cannot handle. So Bellman-Ford algorithm cannot handle cycles for negative edges. Now I will explain Bellman-Ford algorithm with an example. This is an example for Bellman-Ford algorithm. These are various routers A, B, C, D, E, F, G. Total there are 7 routers. So we need to apply shortest distance n-1 times, that is 7 minus 1 times, that equal to 6 times. Now total we need to find shortest distance 6 times. Initially we will mark 0 for source node. I will consider A as source node. So I will mark 0 for source node. And then for all other nodes, we need to mark infinity. Infinity means unvisited. Whenever we visit that particular node, we need to replace infinity with that distance. Now we will write connections. At first I will select A. A is connected to B. And similarly, A is connected to C. And A is connected to D. So I am writing here A, D. And similarly, second one is B. B is connected to only E. So I will write here B, E. And next one is C. C is connected to B and E. So I will write here C, B and C, E. And next one is D. D is connected to C and D is connected to F. So I will write here D, C and D, F. Next one is E. E is connected to G. So I will write here E, G. And next one is F. F is connected to G. So I will write here F, G. And G is last node. No need to write. Now from source node, we need to visit each and every node, and then we need to replace infinity with the distance. First one is A to B. From A to B, distance is 5. So replace infinity with 5. So from A to B, distance is 5. And similarly, from A to C, distance is 5. So replace infinity with 5. And similarly, from A to D, distance is 5. Replace infinity with 5. And from B to E, distance is, from A to B, distance is 5. So 5 minus 1, that is 4. So from B to E, distance is 4. 5 minus 1 is 4. So right here 4. So from C to B, distance is this 5 minus 2, that is 3. 3 is smaller than 5. So replace 5 with 3. So from C to B, distance is 3. And from C to E, distance is, so C node distance is 5. So 5 plus 1, that is 6. But 4 is smaller than 6. Need not to consider. So from C to E, distance is 6. But no need to replace because already 4 is smaller distance. And from D to C, distance is 5. 5 minus 2, that is 3. 3 is smaller than 5. So replace 5 with 3. So from D to C, distance is 3. And from D to F, distance is, D contains distance 5 minus 1, that is 4. So from D to F, distance is 4. And similarly, from E to G, distance is 4 plus 3, that is 7. So replace infinity with 7. And similarly, from F to G, distance is 4 plus 3, that is 7. Already there is 7. And even from F to G, distance is 7. No need to replace. Already there is 7. So we visited first time. We need to visit 5 more times. Second time we will visit. So second time, from A to B, distance is 5. But 3 is smaller than 5. So there is no change. And similarly, from A to C, distance is 5. But 3 is smaller than 5. So there is no change. Similarly, from A to D, there is 5. So already there is 5. There is no change. And next one is B to E. So from B to E, distance is 3 minus 1. That is 2. 2 is smaller than 4. Now we need to replace 4 with 2. So there is change. I replaced 4 with 2. And next one is C to B. From C to B, distance is 3 minus 2. That is 1. 1 is smaller than 3. So replace 3 with 1. So from C to B, distance is 1. And similarly from C to E. From C to E, distance is 3 plus 1, 4. But already 2 is smaller. So there is no change. Similarly from D to C, distance is 5 minus 2. So already there is 3. There is no change. And from D to F, distance is 5 minus 1. That is 4. Already there is 4. So there is no change. And similarly from E to G, distance is 2 plus 3. That is 5. So 5 is smaller than 7. So replace 7 with 5. So replace 7 with 5. And again from F to G, distance is 4 plus 3, 7. So 5 is smaller than 7. So there is no change. So we visited second time. Again we need to visit third time. So from A to B, distance is 5. So there is 1 already. No change. So from A to C, distance is 5. Already there is 3. No change. And similarly from A to D, distance is 5. Already there is 5. No change. And from B to E, distance is 1 minus 1. That is 0. So 0 is smaller than 2. So replace 2 with 0. So here distance is 0. Similarly from C to B, distance is 3 minus 1. Already there is 1. So no change. And similarly from C to E, distance is 3 plus 1. That is 4. But already there is 0. So no change. D to C, distance is 5 minus 2. That is 3. Already there is 3. No change. And from D to F, distance is 5 minus 1. That is 4. Already there is 4. No change. And from E to G, distance is 0 plus 3. That is 3. 3 is smaller than 5. So replace 5 with 3. I replaced 5 with 3. And from F to G, distance is 4 plus 3. That is 7. But 3 is smaller than 7. So no change. And again we will visit fourth time. So from A to B, distance is 5. But 1 is smaller. No change. And from A to C, distance is 5. But 3 is smaller. No change. And again from A to D, distance is 5. But already there is 5. So no change. And similarly from B to E, distance is 1 minus 1, 0. Already there is 0. So no change. And from C to B, 3 minus 2, 1. Already there is 1. So no change. And C to E, distance is 3 plus 1. But already there is 0. No change. And from D to C, distance is 5 minus 2. That is 3. Already there is 3. No change. And from D to F, distance is 5 minus 1. That is 4. Already there is 4. No change. And from E to G, distance is 0 plus 3. 3. Already we have 3. No change. And from F to G, distance is 4 plus 3. That is 7. But already there is 3, which is smaller. So no change. Guys, if you observe here, In fourth visit, there is no change. Guys, in fourth step, there are no changes. So however, in fifth and sixth also there will not be any changes. So now you can stop. So we can stop. Now we got shortest distance from source node to all other nodes. Now shortest path is, so for B1, for C3, and for D5, and for E0, for F4, and for G3. This is shortest path. These are steps in Bellman-Ford algorithm. Guys, in Bellman-Ford algorithm, initially we will select one source node and we will mark 0 for the source node. As initially all nodes are unvisited, we will mark infinity. And whenever we visit each node from source node, we will replace infinity with the distance. And in Bellman-Ford algorithm, if there are n number of nodes, then we need to apply shortest distance n-1 times. For example, if we consider there are 6 nodes, then we will apply shortest distance 5 times. After applying shortest distance 5 times, we will get final result. Guys, in exam you may get question like, explain shortest path algorithms. Then you need to explain both Dijkstra's algorithm and as well as Bellman-Ford algorithm. Next I will explain what is hierarchical routing algorithm. Hierarchical routing is a method used in computer networks to manage routing in a large network efficiently. In this technique, the entire network is divided into smaller regions or groups which are called hierarchies or domains. I will explain with an example. In network, there are so many routers available. So whenever sender want to transfer data to receiver, in large network, data need to pass through various routers. For example, all these are routers. Hierarchical routing will find best route in order to transfer data in large network. So data will be reached to receiver successfully. So hierarchical routing will manage routing in large network efficiently. Guys, for example, this is one big network. In hierarchical routing, entire network is divided into smaller regions. We also call these regions as groups. For example, this entire network is divided into 4 groups. They are 1, 2, 3, 4. So in hierarchical routing, entire network is divided into smaller regions or groups which are called as hierarchies. So this is one hierarchy, this is one hierarchy, this is one hierarchy, and this is one hierarchy. Okay, for example, let us say this is one big network. I am not dividing this big network into smaller regions. As there is big network, in this big network, each and every router need to maintain information about all other routers in the network. For example, if you consider this router need to maintain information about all other routers in the network, and that information is stored in routing table. So each and every router contains routing table. In that routing table, complete information about all routers are maintained. So if we don't divide our entire network into regions, each router need to maintain information about all other routers in the network. So routers will consume lot of space and routing table is very big. And whereas if you consider hierarchical routing, in hierarchical routing, big network is divided into smaller regions. So each router need not to maintain information about all other regions. For example, if you consider this router need to maintain information only about this router and as well as this router, as they are present in one region. This router need not to maintain information about all these routers as they belong to different regions. So in hierarchical routing, each router need not to maintain information about all other routers in other regions. As each router contains routing table, size of routing table is very less. For example, let us say this router want to communicate with this router. As they both belong to same region, they can communicate directly. As for example, if you consider this router is connected to router in other region. As router in one region is connected to other region, we call these routers as special routers. And name of this special router is gateway router. So in this region, this is gateway router because it is connected to other region. And in this region, as this router is connected to this router, this is also gateway router. Router in this region is connected to router in this region. We call these two routers as gateway routers. And similarly, this router and this router, both are connected to each other. So we call this both routers as gateway routers. And similarly, this router and this router, both are gateway routers because they are connected to each other. Now for example, this is source router. This router want to communicate to this router. For example, let's say this is region 1, this is region 2, this is region 3, and this is region 4. For example, this router want to communicate to this router. This router is in one region and this router is in another region. So they cannot communicate directly. So this router will send data to this router, as this is gateway router. It will send data to this router. So if router in one region want to communicate to router in other region, they can communicate by using gateway router. So at first, this router will send data to gateway router. As gateway router is connected to this region, now gateway router will transfer data to this router. So in hierarchical routing, internet network is divided into smaller regions or groups, which are called hierarchies. We also call hierarchies as domains. Each region has its own routers and there is less communication between other regions. Each region has their own routers and there is less communication with other regions. In hierarchical routing, as we are dividing our entire network into various regions, which will reduce the size of routing table. As size of routing table is less, communication will be fast. For example, if you consider larger networks, in larger network, each and every router need to maintain information about all other routers in routing table. So size of routing table is very big. So hierarchical routing will solve this problem by dividing large network into various regions. This is how hierarchical routing will work. And step 1 is, it will divide our entire network into smaller regions. And if communication is within the region, routers can communicate directly. Normally routers will communicate by using distance vector routing or link state routing algorithm. So here, if routers are within the region, they can communicate directly. But if router in one region want to communicate with router in other region, then they need to use special router called gateway router. Through gateway router, router in one region can communicate with router in other region. For example, if this router want to transfer data to this router, they both will communicate each other by using gateway router, as gateway router will connect to region 2. Guys, I will explain hierarchical routing with an example. For example, this is my entire network. My entire network is divided into 4 regions. Region 1, 2, 3 and 4. For example, region 1 contains routers. They are 1A, 1B and 1C. Similarly, region 2 contains routers 2A, 2B, 2C and 2D. And region 3 contains routers. They are 3A, 3B, 3C and 3D. And region 4 contains routers 4A, 4B, 4C, 4D, 4E and 4F. For example, let us say source router is 1A. Now we will create routing table for router 1A, where 1A is source router. From source router, we will find the shortest distance to all other routers in the network. So all these are destination routers. Guys, line is nothing but through which gateway router it need to pass. For example, if you consider region 1, whereas source router is 1A, 1A can directly communicate to 1B and 1A can directly communicate to 1C. So there is no need of any gateway router. These routers can communicate directly. So line is nothing but gateway router. There is no need of any gateway router. As source router belongs to region 1, there is no need of any gateway routers in order to communicate. And for example, if you consider region 2, if router 1A want to communicate to routers in region 2, then this router can communicate by using router 1B, where 1B is gateway router because router 1B is connected to region 2. So if router A want to communicate to 2A, 2B, 2C and 2D, then it need to communicate by using gateway router 1B. So in order to communicate to region 2, we need gateway router, that is 1B. And similarly, routers in region 2 want to communicate to region 3, then they can communicate by using gateway router, that is 2D. And similarly, if region 1 want to communicate to region 4, then they can communicate by using gateway router, that is 1C. By using router 1C, region 1 can communicate to region 4. So for region 4, 1C is gateway router. As for example, if router 1A want to communicate to itself, then there is no need of any router. They can communicate directly. So there is no need of any hops. Guys, hop is nothing but through how many router our message need to pass in order to reach to destination. And whereas if 1A want to communicate to 1B, then 1A can communicate to 1B directly. So through 1A, data will be reached to 1B. Through router 1A, data will be reached to 1B. So there is only single router. So hop is nothing but through how many routers it need to pass. Through single router, data will be passed from source to destination. And similarly, if 1A want to communicate to 1C, it can communicate directly. Through single router 1A, data will be reached to 1C. So here also hop count is 1 because data will be passed through single router. Now destination router is 2A. If router 1A want to transfer data to 2A, then at first 1A will transfer data to 1B, which is gateway router. Through 1B, data will be reached to 2A. So data will be passed by using two routers. So your hop count is 2. And similarly, next destination is 2B. So through router 1A, 1B, and then 2A to 2B. So through router 1A, 1B, and 2A, data will be reached to 2B. So your hop count is 3. And similarly, next one is 2C. Through 1A, data will be reached to 1B, and then 2A. Through router 2A, data will be reached to 2C. So here also hop count is 3. And next one is 2D. Through 1A, data will be transferred to 1B, and then 2A. Then from 2A, data can be transferred to either 2B or 2C. Then data will be transferred to 2D. Through 1A, data is forwarded to 1B, and then 2A, and then 2B. From 2B, data is reached to 2D. So by using 4 routers, data will be transferred to receiver. So your hop count is 4. And next one is region 3. From 1A, if data want to reach to 3A, then first from 1A, data is transferred to 1B, and then 2A, and then 2B, and then 2D. From 2D, data is transferred to 3B. From 3B, data is transferred to 3A. So from router 1, 2, 3, 4, 5, 6, data will be reached to 3A. So here hop count is 6. And next one is 3B. Through router 1A, 1B, 2A, 2B, 2D, data will be reached to 3B. So here hop count is 5. And similarly, next one is 3C. So from 1A, 1B, 2A, 2B, 2D, 3B, data will be reached to 3C. So hop count is 1, 2, 3, 4, 5, 6. So hop count is 6. So data need to pass through 6 routers in order to reach to 3C. And next one is 3D. So from router 1A, 1, 2, 3, 4, 5, 6, 7. So through 7 routers, data will be reached to 3D. And next destination is 4A. Thus we can transfer data either by using this route or this route. So I'll select this route. So source router is 1A and destination router is 4A. So at first step, from 1A, data will be transferred to 1C, and from 1C, data is transferred to 4B and then 4A. So by using 3 routers, data will be reached to 4A. So here hop count is 3. And next one is 4B. So through router 1A and 1C, data will be reached to 4B. So here hop count is 1, 2. And next one is 4C. So at first data is transferred to 1C and then 4B and then 4C. So here hop count is 1, 2, 3. And next one is 4D. Here source router is 1A and destination router is 4D. Through router 1, 2, 3, 4, data will be reached to 4D. So here hop count is 4. And next one is 4E. Through router 1, 2, 3, 4, 5, data will reach to 4A. So your hop count is 1, 2, 3, 4, 5. So your hop count is 5. And last destination router is 4F. So from 1A, data is transferred to 1C and then 4B and then 4A. From 4A, data is transferred to 4F. So your hop count is 1, 2, 3, 4. So your hop count is 4. Guys, in exam, no need to write all this. Just you can draw this table. Guys, here 1B and 2A. Both are connected to each other. So we call this 1B and 2A as gateway routers. Similarly, 2D and 3B. Both are gateway routers. And 3D and 4C. Both are gateway routers. And 1C and 4B. All these are gateway routers. By using gateway routers, regions can communicate to each other. So this table will show how communication will happen between source router to all other routers in the network. This is complete routing table, but each router will not store this complete routing table. Each router will store hierarchical routing table. In hierarchical routing table, each router will store full details of its region and only summary of other regions. By seeing this table, you can understand. For example, source router is 1A. So, as router 1A belongs to region 1, this router 1A will store complete information about all routers in that particular region. So, router 1A will store information about 1A, 1B and 1C. Source router is 1A. This router can communicate itself directly. So there is no need of any lines and hops. And in order to reach to 1B, 1A will directly communicate to 1B through router 1A. 1A will directly communicate to 1B. So hop count is 1. And 1A will directly communicate to 1C through 1A. 1A will directly communicate to 1C. So here also hop count is 1. And similarly, in order to reach to region 2, if 1A want to reach to region 2, it will communicate by using gateway router 1B. So here gateway router is 1B. As 1B is connected to 2A, in order to reach to 2A, hop count is 2. So if 1A want to communicate to region 3, 1A will communicate to region 3 by using gateway router 2D. So in order to reach to 3B, hop count is 5. And similarly, if 1A want to communicate to region 4, it will communicate by using gateway router, that is 1C. So 1C is connected to 4B. So in order to reach to 4B, hop count is 2. Now this is complete hierarchical routing table. Each router will store complete information of its region and then it will store only summary of other region. So this is hierarchical routing table where each router will store this hierarchical routing table. As each router will not store this complete information, size of routing table decreases in hierarchical routing table. These are advantages of hierarchical routing. Hierarchical routing will reduce routing table size. Hierarchical routing has better scalability. Yes, better scalability means even if there is large network, hierarchical routing will work well for large networks. And third advantage is fast convergence. Guys, convergence means stabilization. For example, just due to some network problem, router will transfer data by using other route. So only that region will get affected, not entire network. These are disadvantages of hierarchical routing. And the first one is complex setup. Hierarchical routing will divide our entire network into smaller regions, so which is very hard to set up. So we need to plan it carefully. And second one is less optimal paths. Hierarchical routing will not choose shortest path always. Instead, based on network condition, sometimes hierarchical routing may also choose longest path. And third one is gateway failure. If gateway router fails, then regions cannot communicate. And fourth one is higher cost. Because hierarchical routing need more equipments and as well as more maintenance. So it is costly. And fifth one is slightly slower. Communication between routers from one region to other region is slow. Next I will explain what is flooding and then I will explain what is selective flooding. I will explain with examples. First I will explain what is flooding. Flooding is a method to send data in computer network. When one computer sends data, it sends it to all the connected computers called neighbors. Those neighbors again send it to their neighbors. This continues until data reaches to all parts of the network. Guys, not only computer, there can be any device. For example, if you consider router, one router will send data to all the connected routers. And similarly, those routers will send data to their neighbors. Like that, data will keep on flooding until data is successfully reached to destination. For example, let us say there is router A. This router A wants to send data to router D. But this router A don't know path to reach to router D. So what this router A will do is, router A will send data to all its connected routers. As router A is connected to router B and router C, now router A will send data to B and C, as B and C are their neighbors, and B will send data to their connected routers. As B is connected to D, B will send data to D, and similarly C neighbor is D. So C will send data to D. Now data will be reached to destination, that is D. So in flooding, each router will send data to all its connected routers, and similarly the routers will send data to their neighbors. Like that, data will keep on flooding until data is successfully reached to destination. These are applications of flooding. Yes, applications are nothing but where this flooding is used. And the first one is broadcasting in networks. Guys, we will use flooding in broadcast networks. For example, If one computer wants to send data to all its connected computers, threading technique is used. And second one is used in dynamic routing protocol. Because dynamic protocol like OSPF, where OSPF stands for Open Shortest Path First. This OSPF will use threading. And third one is used in unknown networks. If sender don't know path to reach to destination, in that situations, threading technique is used. These are disadvantages of threading. And the first one is too many messages. As each router will keep on sending data again and again to their neighbors, which will cause many copies of the data. And second disadvantage is bandwidth wastage, as messages will keep on repeating, which will consume lot of space, which will slow down the network. In order to overcome this problem, we can use protocols like Dijkstra's algorithm and distance vector algorithm. By using these techniques, we can find the shortest route in order to reach to destination. So instead of using threading, you can use techniques like Dijkstra's algorithm or distance vector routing algorithm. And third one is loops can happen. Because sometimes messages will keep on going in circular manner and will never stop. In order to overcome this problem, we need to give sequence number for our messages. So whenever destination router receives the data based on sequence number, receiver router will identify whether message is already received or not. So in threading, loops can happen. Loop is nothing but repeating our data again and again in circular manner. So in order to overcome this problem, we need to give sequence number to our messages. And fourth one is conjunction. Thus conjunction means high traffic in network. As each router will keep on sending data to their neighbors, traffic will be very high in network, which will cause delay in data transfer and even sometimes complete data will be lost. Next I will explain what is selective threading. Name itself says selective threading. So instead of sending data to all their neighbors, we will send data to only selective neighbors. So selective threading is a better version of threading. In this, the computer send data only some of its neighbors, not all. Those neighbors will again send data to their neighbors. So messages will reach to destination. Instead of sending data to all neighbors, data will be forwarded only to selective neighbors, which will reduce number of messages in network. So when compared to threading, selective threading is fast. This is example. For example, this computer wants to send data only to this computer. As this computer is connected to this router and this router, instead of sending data to all its routers, this computer will send data to only this router. So by using this router, data will be reached to destination. This is meaning of selective threading. Next I will explain what are various broadcast routing algorithms. Before that, at first you need to know what is broadcasting. Yes, for example, there is one computer. This computer wants to send data to all these computers. If you consider unicasting, in unicasting, we can send a message to only single computer at a time. So at first, that message is transferred to this computer, after that this computer, and after that this computer. Like that, sender need to send each message to each computer. So this computer need to send same message 5 times. So in unicasting, each message is transferred to single computer at a time. For example, let us say this computer wants to send data, that is hello. This computer will type single message and then this computer will send data to all these computers at once. This is meaning of broadcasting. Sending data to all its connected computers at once is known as broadcasting. Where these are various broadcast routing algorithms. And the first one is distinct point-to-point protocol. Yes, actually it is like unicasting. Sender need to send separate unicast message to each destination. For example, let us say sender want to send 5 messages to 5 people. For example, let us say sender want to send single message to 5 people. So sender need to send the single message 5 times. As sender is sending same message 5 times, which will consume lot of space as there are duplicate messages. And second one is threading. Guys, I already explained what is threading. This threading technique is example of broadcast routing, as we will send data to all its connected neighbors. Problem with threading technique is, as we are sending too many duplicate messages, network will be overloaded. And third one is multi-destination routing. As for example, sender want to transfer data to this computer and this computer. So there are multiple destination computers. At first this computer will check how to reach to this computer and this computer. Based on that, this computer will transfer data to this computer and this computer. So instead of sending data to all its connected neighbors, sending data to only selective routers, the selective routers will send data to receiver successfully. This is known as multi-destination routing, but this technique is not suitable for larger networks. And fourth broadcast routing algorithm is spanning tree. That loop is like circle, repeating same message again and again. So what this spanning tree technique will do is, spanning tree technique will create loop-free tree, and in spanning tree, each router will forward data to child routers until data is reached to receiver. Fifth broadcast routing algorithm is reverse path forwarding. Shortly we call it as RPF. In reverse path forwarding, router will forward data packet only if the packet is received from shortest path. For example, router A want to send data to router D. As for example, at first B forwarded data to D. B path is shortest. In this route, data is reached to D at first. After some time, again in this route, data is reached to D. As this path is longest path, router D got same message after some time. Now this router D will reject this message because already router D got message from router B. Already router D received message. Next I will explain what is congestion control, and then I will explain types of congestion control. Yes, congestion means too much data in computer network, which will slow down the internet. Yes, for example, if multiple computers send data at the same time in computer network, which will cause traffic jam and slowing down the internet. So congestion happens when too much data is sent through a network, making network slow and causing delays. That means data will reach to receiver very slow, and sometimes data packets may lost, and even sometimes entire network will crash. And whereas congestion control means managing network traffic when there is too much data trying to pass through a network at the same time, leading to slow down the internet, and sometimes packets may be lost and there is delay in communication. So congestion control will help network to work properly. In simple terms, congestion control means managing network traffic when there is too much data passing through a network. Yes, congestion control is divided into two types. They are open loop congestion control and closed loop congestion control. Retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. All this belongs to open loop congestion control, and whereas back pressure, choke point, implicit and explicit signaling, all this belongs to closed loop congestion control. So congestion can be controlled by using these two methods. At first I will explain what is open loop congestion control. We also call it as prevention method. This method will prevent congestion before it occurs. Name prevention method. That means before congestion occurs, we will try to avoid congestion. So this method prevents congestion by using proper design rules. It is handled by the sender or receiver. And the first one is retransmission policy. Name itself says retransmission. That means if data is lost or corrupted, sender will send that same data again. And second one is window policy. If many packets are sent at once, then congestion will occur. In order to overcome this problem, we can use window policy. That is nothing but we need to set window size. For example, I will set window size as 3. That means only 3 packets can be sent at a time. For example, if I give window size as 5, we can send only 5 packets at a time. So which will avoid congestion. And third one is acknowledgement policy. Yes, acknowledgement means reply message. Whenever sender sends data to receiver, receiver will give reply whether data is received successfully or not. This is meaning of acknowledgement. Receiver, instead of sending reply to each and every packet, receiver will give reply at once to multiple packets, which will reduce network load. And fourth one is discarding policy. Yes, for example, if multiple computers send data at the same time in network, then congestion will occur. Congestion is nothing but traffic jam. So in order to overcome this problem, if multiple computers send data at the same time, then we need to accept only important packets, and then we need to discard less important packets. So routers will discard less important packets during congestion in order to maintain network performance. And fifth one is admission policy. That is nothing but giving admission to only limited users. So only limited number of users can send data at the same time in network, which will prevent congestion. These are various kinds of techniques used in open loop congestion control. Next I will explain what is closed loop congestion control. Closed loop congestion control is nothing but handling congestion after it happens. Guess when congestion occurs, computers will slow down the data transmission until congestion is cleared. This technique will make sure that data will flow smoothly in network. This closed loop congestion control will detect and control congestion using feedback mechanisms. These are various feedback mechanisms. And the first one is back pressure. Just for example, sender want to transfer data to receiver through multiple routers. In back pressure technique, whenever congestion occur, that particular router will inform to previous routers. For example, if you consider router 3, many people are transferring data by using router 3 at the same time. So in router 3, there is high traffic. That is nothing but there is conjunction. That is, computer is continuously forwarding data. This router will inform to this router that conjunction occurred. And similarly, this router will inform to this router. So sender will send data very slow. So in back pressure, if conjunction occurred to particular router, then it will inform to previous router to slow down the data transmission. This process will continue till the source router. This is all about back pressure. And second one is choke packet. Same example. So whenever conjunction occurs, then this router will send special packet to source router. So a special packet is sent by the router to source computer, telling to reduce data flow. So whenever this computer receives choke packet, this computer will now send data very slow. This is all about choke packet technique. And third one is the implicit signaling. In implicit signaling, we will not get reply from receiver. Instead, source computer will indirectly identify conjunction by observing lost packets and delays. So in implicit signaling, routers will not give any message to computer. Indirectly, computer will identify conjunction occurred or not by observing delays and lost packets. And fourth one is explicit signaling. Whereas in this technique, routers will directly inform to computer that conjunction occurred. And this technique is used in connection-oriented networks. Explicit signaling is classified into two types. They are backward signaling and forward signaling. Name itself says backward signaling. So whenever conjunction occurs to particular router, that router will inform to source computer by asking to slow down the data transmission. And whereas in forward signaling, whenever conjunction occurs to particular router, that router will forward alert message to destination computer by sending message that conjunction occurred. Next, I will explain what are various congestion control approaches. I will explain what is provisioning, admission control, traffic aware routing, load shedding and traffic throttling. And then I will explain what are various methods used to control congestion. Guys, whenever multiple computers send data at the same time in network, there is huge amount of data in network which will cause traffic jam. So congestion is nothing but huge amount of data in network which will cause traffic jam. Congestion will cause delay, that is nothing but data will reach to receiver very slow, and then sometimes there is loss of data and also network performance will decrease due to congestion. So by using various congestion control approaches, we can prevent congestion. By using various congestion control approaches, we can keep our network running smoothly, which will avoid overloading and allows data to flow efficiently. These are various congestion control approaches. And the first one is provisioning. Guess whenever congestion occurs in network, in order to avoid congestion, we use provisioning technique. In provisioning technique, we will add extra resources like routers and cables in order to avoid congestion. Guess normally there is engineering team. This engineering team will identify our network condition and they will update our network whenever new technologies are available. So this provisioning, that is nothing but adding extra resources like routers and cables are done by engineering team. Next congestion control approach is admission control. Guys, in admission control technique, new connections are not given to devices whenever network is overloaded. Only if network is not busy, then new connections are given to devices. Guys, for example, if you consider phone system, if too many people try to make call at the same time, then phone system will become overloaded. When phone system is overloaded, then new calls are not allowed. Only if phone system is not too busy, then new calls are allowed. Because this admission control technique is simple to implement for phone lines, but it is harder to implement for computer networks because computer network contain different types of devices with different sizes and with different capacities. That is why admission control technique is hard to implement for computer networks. Next congestion control approach is traffic aware routing. Guys, in this technique, whenever a particular line is too busy, then data will be transferred by using other line. Guys, in traffic aware routing, each and every link is given some weight. Less weight means line is not too busy, and whereas high weight means line is busy. For example, this computer want to transfer data to this computer. This computer will transfer data by using this line. In this particular line, traffic is very high. That is nothing but line is busy. So in this particular line, if line is busy, then simply data will be transferred by using other line. So now data will be transferred by using this line. So when compared to 5, 3 is smaller. That is nothing but this line is less busy. So now instead of this line, data will be transferred by using this line. Yes, for example, 10 computers want to transfer data at the same time. So now 10 computers will identify that this line is busy. So now again 10 computers will shift to this line. So instead of this line, all these 10 computers will shift to this line. Again this line also will become busy. So at a time, if too much traffic is sent to other line, then other line also becomes busy. Then data will be reached to receiver very slow. And this problem can be solved by using two techniques. One is multipath routing and second one is gradual traffic shifting routing scheme. Thus in multipath routing, instead of shifting complete traffic to other route at a time, devices need to select multiple paths. For example, some device will select this path, some device will select this path, and some device will choose some other path. And whereas gradual traffic shifting routing scheme is nothing but, instead of shifting complete traffic to other route suddenly, complete traffic must be shifted to other route gradually. Instead of 10 devices moving to other route at a time, at first some device will move to this route. So some device transferring data, again some device will move to this route. Like that, instead of shifting complete data at a time to this route, gradually device need to shift data. So data will be reached to receiver very fast. Fourth congestion control approach is load shedding. As in load shedding, whenever traffic is full, that is nothing but whenever multiple devices send data at the same time in network, if router cannot handle that much data, then router will discard some data packets. So load shedding means router will discard some packets whenever router cannot handle incoming traffic. As for example, let us say this router can handle only 10 packets, but at a time 20 packets are received to this router. Now router need to discard 10 packets. Now router will discard 10 packets based on two techniques, wine strategy and next one is milk strategy. As in wine strategy, older packets are more important than newer packets. So whenever multiple devices send data at the same time, if router cannot handle that much data, older packets are selected and then newer packets are discarded. As we know, old wine is costly. Even in computer networks, old data packets are important when compared to new packets. And whereas milk strategy is opposite to wine strategy, in milk strategy, new packets are accepted and old packets are rejected. So if router cannot handle too much data, then router will accept new packets and then router will reject old packets. Guys, load shedding will also follow other technique in order to discard packet. The technique is nothing but priority based discarding. Guys, in priority based discarding, whenever particular computer send data, then along with data, it will include priority number. So data with highest priority number is accepted and data with small priority number is rejected. In case if router cannot handle that many packets. Guys, you also need to know what is RED. That is nothing but random early detection technique. As RED technique will control congestion by discarding packets before buffer is completely full. So this technique will prevent congestion. As for example, let us say router size is 5. That is nothing but router can handle only 5 packets at a time. Actually, whenever buffer size is 5, then packets must be discarded. But in this RED technique, before buffer is full, packets are discarded. So whenever buffer size reaches to 4, packets will be discarded. So congestion will not occur. And fifth congestion control technique is traffic throttling. As in traffic throttling technique, whenever congestion occurs, then speed of network is decreased. For example, network is overloaded. So whenever network is overloaded, then internet service providers like Act5net, Jio, Airtel, they will get alert message. Whenever they receive alert message, then they will slow down the internet speed. So before congestion occurs, internet service providers will get alert message that congestion is going to occur. So whenever they receive alert message, they will slow down the internet speed. As internet speed is decreased, now data will reach to receiver very slow. So congestion will be avoided. So traffic throttling technique is also known as congestion avoidance technique. As traffic throttling technique will follow two main operations. One is predicting congestion and next one is notifying routers and senders. If there is too much data in queue for particular router, then congestion is about to occur. Now router will identify which sender is causing congestion. That is nothing but which sender is sending too much data. Now router will send alert message to particular sender in order to slow down the data transfer. Based on how much data is in queue, router will identify whether congestion will occur or not. Whenever there is chance for congestion, now router will inform to sender to send data very slow. These are two operations performed in traffic throttling. Next I will explain various methods used to control congestion. And the first one is warning bit method. Guess for example, There are so many devices transferring data through this router, and this particular computer is sending too much data through this router. As conjunction is about to occur, now this router will send special bit as acknowledgement. This special bit is known as warning bit. So whenever this computer receives warning bit, now this computer will understand that conjunction is about to occur. Now this computer will send data packet slowly. This is known as warning bit method. The next method is choke packet method. The choke packet method is same like warning bit method. So instead of sending warning bit, a choke packet is sent to sender. Whenever this computer receives choke packet, now this computer will send data slowly in order to avoid conjunction. This is diagram. Router A is sending data very fast. So whenever conjunction occurred for router F, now router F will send choke packet to router A in order to slow down the data transmission. Thick arrow mark will represent faster data transmission. So there is maximum flow. So whenever router A receives choke packet, now router A will send data slowly. There is reduced flow. And third method is hop by hop choke packet. That's hop is nothing but router. That's in hop by hop choke packet. Whenever conjunction occurs to particular router, then that router will inform to its connected router. I'll give example. This computer wants to send data to this computer, but for this particular router, conjunction occurred. So whenever conjunction occurred, this router will send choke packet to this router, and similarly, this router will send choke packet to this router, and similarly, this router will send choke packet to this computer. Now this computer will understand that for this particular router, conjunction occurred. Now this computer will send data slowly in order to avoid conjunction. This is diagram. This router A is transferring data very fast. So for this particular router D, conjunction occurred. As router D is connected to E, router D will send choke packet to E, and then E will send choke packet to F, and then G, H, and then H will send choke packet to A. Whenever router A receives choke packet, now router A will send data slowly. This is meaning of hop by hop choke packet. Next I will explain what is internetworking. Internetworking means connecting two or more different networks to make them work as one big network. It allows communication between computers on different networks, even if they use different technologies. Internetworking is done using devices like routers, gateways, switches and hubs. This is structure of internetworking. For example, one software company has different branches in different locations. 1, 2, 3, 4, 5, 6, 7. All these are various software company branches in different locations. And all these are connected through various routers. So A, B, C, D, E, F, G, H, I. All these are various routers. All these branches are connected to each other through routers. This structure of internetworking. Different networks are connected to each other either by using routers or gateways or switches or hubs. And internetwork routing means sending data from one network to another network through various routers. This is meaning of internetworking routing. Next I will explain why internetworking is needed. For example, one software company branch is in Hyderabad and next software company branch is in Delhi. If two branches want to communicate each other, then we need internetworking. So we need internetworking in order to connect the networks from different locations. Different networks like local area network, wide area network, metropolitan area network, all can communicate to each other through internetworking. Through internetworking, we can send data and resources to different departments, different branches, and even different countries. That is why we need internetworking. So I will explain various types of internetworking scenarios. And the first one is LAN to LAN internetworking. Guys, in LAN to LAN internetworking, two local area networks are connected to each other. This is example. In city, there are two college buildings. Two buildings are side by side and they are connected to each other through router. This is example of LAN to LAN internetworking. And next one is WAN to WAN internetworking. Here two wide area networks are connected to each other. I'll give one example. For example, one bank is in one city and next bank is in other city. Both offices are connected to each other through leased line. Leased line is nothing but cable. This is example of WAN to WAN local area network. And third one is LAN to WAN internetworking. Here, local area network is connected to wide area network. I'll give one example. For example, if you consider college building is considered as local area network. And all the computers in your college is connected to internet. So internet is WAN, that is wide area network. So college building connected to internet. This is example of LAN to WAN internetworking. And fourth one is LAN to WAN to LAN internetworking. Here, two local area networks are connected to one wide area network. I'll give one example. For example, there is a software company. That software company has 4 branches. One branch is in UK, next branch is in India, next branch is in US, and next branch in London, and main branch in Australia. All these branches are connected to main office through internet. This is example of LAN to WAN to LAN connection. All these are various internetworking scenarios. Guys, normally in order to connect to different networks, these are various devices we use. And the first one is routers, and next one is gateway, and next one is switch, and next one is hub. We use routers in order to transfer data, and gateway will connect to different networks using protocols. And if many devices are in same network, all these devices are connected to each other through a switch. And hub is used in old LANs in order to connect to multiple computers. These are various devices that we use in Internetworking. Next, I will explain what is fragmentation. Fragmentation in computer networks mean breaking a large data packet into smaller pieces, so it can pass through a network that has smaller size limit. Yes, I will give an example. Yes, for example, I am sender who is in India and my friend is in UK. I want to send some data packet like, hi, how are you? For example, the data packet size is 3000 bytes. But whatever the network I am using, that network can handle maximum size of 1000 bytes. So what I will do is, I will break my 3000 bytes data into 3 parts, known as 3 fragments. Each fragment contains 1000 bytes. Whenever data is reached to receiver router, in receiver router, again data is arranged in order, so receiver can read the data. MTU means maximum transmission unit. If data packet is larger than MTU, then our data must be divided into smaller packets. We call this process as fragmentation. Yes, fragmentation is classified into 2 types. One is transparent fragmentation, and next one is non-transparent fragmentation. Before data reaches to destination computer in network, in middle of data transmission, all packets are reassembled in order before reaching to destination. So whenever receiver receives data, as all packets are arranged in order, receiver can read original message. And next one is non-transparent. In non-transparent, data packets are not reassembled in order in middle of network. Whenever receiver router receives data packets, then receiver need to rearrange the data packets in order. I will explain what is tunneling. Tunneling is a process used in computer networks to send data from one network to other network by placing packets inside other packet. This helps in sending data securely between different types of networks. So it acts like tunnel that carries original data through different networks. Yes, I will give an example. This is example. For example, sender want to send IPv6 data, but my network is IPv4. So IPv4 cannot handle IPv6 data. So now this IPv6 data is placed inside IPv4 data. So outside part is IPv4, but inside data is IPv6. We call this process as tunneling. As now our packet is IPv4, data will be successfully reached to receiver. So whenever receiver receives data, receiver will remove top IPv4 and then receiver will read IPv6 data. These are various uses of tunneling. And the first one is VPN, that is virtual private network. As we are placing one packet inside other packet, data will be transferred securely. So tunneling acts as private network. And second one is IPv6 over IPv4. We can send IPv6 data through IPv4 network using tunneling. And 2 different LANs can communicate to each other through tunneling by using internet. These are various protocols we use in tunneling. And the first one is GRE. We use GRE for simple tunneling. And IPsec, that is IP security, for securely tunneling data. And L2TP, we can use this protocol along with IPsec protocol for security. And next one is 16.4. If you want to send IPv6 data over IPv4 network, then we can use this protocol, that is 16.4 protocol. These are common protocols we use in tunneling. Next I will explain what are quality of services. Quality of services are techniques used in computer networks to control and manage network traffic. Quality of service will give better service to important data like voice, video and online calls. So quality of service can reduce delay, that is nothing but data will be transferred very fast to receiver and there is no packet loss and there is no jitter in network. These are techniques used in quality of services. And first one is classification. Yes, we need to classify our data like separating voice calls, video files, audio files, etc. And second one is queuing. Queuing is nothing but arranging data based on priority. For example, let us say there are so many people sending data. The data contains voice calls, video calls, important files, etc. Then at first we need to place important files in queue and then voice calls and then videos. So we need to arrange data based on priority. This is meaning of queuing. And next one is scheduling. Scheduling is nothing but sending highest priority data first. For example, if there is any important data in network, then the data need to be transferred first. And fourth one is traffic shaping. Traffic shaping means controlling the speed of data flow. Like how much speed receiver can receive data, only in that speed sender need to send data. This is meaning of traffic shaping. And fifth one is resource reservation. Guys, for example, there are so many routers in network, but we must not use all routers. So we need to keep some routers side for future use. Okay, these are various attributes used to describe data flow and quality of services. And first one is bandwidth. Guys, bandwidth means how much amount of data that can be sent in a second. Generally, bandwidth is measured in terms of Mbps. that is how much MB of data that can be transferred per second. If you are sending video files, it will occupy more Mbps, and whereas if you are transferring text files, which will consume less MB per second, that is nothing but less bandwidth. And second one is delay. We also call delay as latency. How much amount of time required in order to transfer data from sender to receiver. Generally, there is less delay for real-time applications like voice calls and video calls. And third one is jitter. The jitter means difference in arrival time of data packet. Because for example, if we send any data, receiver need to get the data very fast. So low jitter means data will reach to receiver smoothly, and high jitter means data will reach to receiver very slow. And fourth one is packet loss. Because whenever sender transfer any data packet, due to some disturbance in network, that packet may be lost. So packet loss will decrease quality of service. And fifth, throughput. Throughput means how much amount of data received by receiver in given time. We call it as throughput. Throughput depends on bandwidth, network condition, and congestion. Congestion means traffic. And sixth one is reliability. Reliability means how much amount of data received to receiver without any errors. That is nothing but how much correct data received to receiver. Thus, reliability is very important, mainly for online banking and file transfer, as they need to reach to receiver without any errors. Next, I will explain what is ICMP, that is Internet Control Message Protocol, and what is DHCP, that is Dynamic Host Configuration Protocol. This ICMP protocol is used to send error messages and as well as control messages between devices in a network. ICMP protocol will not send data, it will send only problems related to data delivery. ICMP protocol is used inside IP protocol, and ICMP protocol is used by tools like ping and traceroute. ICMP protocol is used to send error messages and as well as control messages between devices in a network. So I'll explain what are error messages and control messages with an example. At first I'll explain how ICMP will send error messages with an example. Guys, ICMP protocol is used inside network. For example, device A want to transfer data to device B. So whenever device A transfer data through various routers, data will be reached to device B. But whenever device A transfer data, device B is far away. So data is not reached to device B. As data is not reached to device B due to long distance, now ICMP protocol will send message to device A that destination is unreachable. This is example of error message sent by ICMP protocol whenever device is unreachable. For example, whenever device A transfer data, as device B is far away, it is taking long time in order to reach data to device B. So after waiting some time, as data is not reached to device B, now ICMP protocol will send error message, that is time exceed. These both are examples of error messages sent by ICMP protocol. And ICMP also sends control message. I'll explain what are control messages with an example. We also call this control message as ICMP redirect. As for example, this is router 1 and this is router 2. So now device A will transfer data through router 1. But this router 1 knows that router 2 is faster than router 1. If data is transferred through router 2, data will be reached fast to receiver. So this router 1 will send ICMP redirect message to device A. This message will tell device A that next time transfer data by using router 2 instead of router 1, as router 2 is faster than router 1. So ICMP redirect. This is example of control message. ICMP protocol will not send data. Instead, ICMP protocol will send error messages and as well as control messages between devices in a network. These are uses of ICMP protocol. And the first one is check if your device is reachable. ICMP protocol will check whether the device is working or not, whether the device is connected to network or not. And second use is reporting errors. Whenever one device is transferring data, if anything goes wrong, then ICMP protocol will send error messages back to sender. Okay, these are important ICMP messages. And the first one is echo request. Guys, echo request. By using this message, we can check whether a particular device is active or not. But generally it is used in ping command. And second one is echo replay. Yes, whenever sender send echo request to receiver, receiver will give echo replay. As sender got echo replay, now the sender will understand that he can send data to receiver as this device is active. And third message is destination unreachable. I already explained this. Whenever device is not reachable, sender will get message like destination unreachable. And time exceed. Whenever sender transfer data, after a particular point of time, if data is not reached to receiver, then sender will get time exceed message. And fifth one is redirect message. This redirect message is sent by router to suggest a better route to send data. Next message is source quench. This message will ask sender to send data very slow. But at present, we are not using this message. These are various important ICMP messages. Next I will explain what is DHCP, that is Dynamic Host Configuration Protocol. Whenever any device is connected to network, DHCP protocol will automatically assign IP address to particular device. I will explain with an example. As for example, one computer is connected to network, but this computer does not have any IP address. And whereas DHCP protocol is used inside server, where DHCP protocol contains list of IP addresses. And this computer does not have any IP address. Now this computer will send DHCP discover message to DHCP server. DHCP discover message means sending request for IP address. A DHCP server contains list of IP addresses. Now DHCP server will select one IP address and then DHCP server will assign IP address to a particular device. For example, the server will assign IP address like 192.168.0.2 and we call this message as DHCP offer message. Whenever particular computer sends DHCP discover message, DHCP server will send DHCP offer message by assigning particular IP address. And whenever computer receives this IP address, again this computer will send response to DHCP server, like whether this computer will accept this IP address or not. If this computer accepts this IP address, then this computer will send acknowledgement to server. This whatever the IP address given by DHCP server, this IP address is not permanent. So along with IP address, DHCP server will set some leash time. Leash time is nothing but how much time particular computer can use this IP address. So whenever time expires, IP address will be lost. These are advantages of DHCP server. And the first one is automatic IP assignment. As each and every device will get IP address automatically, so we need not to set manually. So there will be no human errors and network can be managed efficiently. And second one is efficient use of IP addresses. DHCP server automatically assigns IP address to various devices. So it will manage IP addresses efficiently. And third one is centralized management. As there is only single DHCP server which will give IP addresses to various devices in the network. So various devices can directly connect to the server and they can take IP address. So management is very easy. These are three advantages of DHCP server. Next I will explain what is IP addressing. Guys, IP address is nothing but it is unique number given to each and every device in a network. By using this unique number, sender can send data to receiver. Guys, there are two types of IP addresses. One is IPv4 address and next one is IPv6 address. IP address which has 4 numbers separated by dots. This is example of IPv4 address. So this is one number, dot, number, dot, number, dot, number. So there are 4 numbers separated with dots. This is example of IPv4 address. Yes, for example, this computer want to send data to this computer in internet. So whenever this computer want to send data to this computer, so along with data, this computer need to enter IP address of this computer. For example, this computer IP address is 192.168.0.2. So along with data, this computer need to include IP address of this computer. So data will be reached to this computer based on this IP address. Yes, normally we can assign IP address to each and every device manually. Or there is one server called DHCP server, where DHCP stands for Dynamic Host Configuration Protocol. This server will automatically give IP address to each and every device. So IP address can be given manually or automatically. We can do it manually, or there is server called DHCP server. It can assign IP address automatically to each and every device. Just for example, there is computer network. This computer IP address is 192.168.0.1. There are 4 numbers separated by dots. This is example of IPv4 address, where v4 stands for version 4. This IPv4 address is divided into 5 classes. They are class A, B, C, D and E. I will explain each and every class in detail. In network like internet, communication is possible between devices based on IP addresses. Each and every device contains unique IP address and data will be reached to a particular device based on this IP address. IPv4 address is divided into 5 classes and the first one is class A IP address. Guys, class A IP address is used in big networks. Big network is nothing but that network will support 16 million plus devices. But how can we identify that particular computer belongs to class A IP address? For example, let us say this computer IP address is 2.1.1.1. For example, if you consider starting number, that is number 2, this number is in between 1 to 126. If starting number is in between 1 to 126, then we consider it as class A IP address. So this computer IP address is class A IP address. So class C IP address ranges from 1 to 127, but we will use only 1 to 126. We don't use 127 because number 127 is used when device want to send data to itself. And second one is class B IP address. Yes, class B IP address is used in medium networks. Medium networks mean we can give class B IP address to approximately 65,000 plus devices and exactly 65,534 devices. We can give IP address to these many devices. Yes, whereas if you consider class A IP address ranges from 1 to 127. And whereas if you consider class B IP address ranges from 128 to 191. So starting number is from 128 to 191. As for example, in network, this computer IP address is 129.0.0.1. So starting number is 129. As this range is in between 128 to 191. So this computer IP address is class B IP address. And second number, third number and fourth number. These numbers can be in between 0 to 225. And third one is class C. Class C IP address is used in smaller networks. Class C will support exactly 254 devices. That is nothing but class C IP address is given to maximum 254 devices. Class B IP address ranges from 128 to 191 and whereas class C IP address ranges from 192 to 223. And next one is class D IP address. Yes, class D is used for group communication. That is nothing but multicasting. Multicasting means if one computer wants to send data to many devices at once, then this computer need to use class D IP address. Class D IP address ranges from 224 to 239. So starting IP address ranges from 224 to 239 and second, third, fourth. These numbers can be in between 0 to 225. So class D is used for group communications for sending data to many systems at once. And next one is class E IP address. Guys, normally no one will use class E IP address. Class E IP address ranges from 240 to 255. Regular device will not use this IP address. This IP address is reserved for future and research use. Here just you can remember these numbers. So 128 mean here you need to reduce to 127. And similarly 192. 192 mean here you need to reduce to 191. And similarly here 224. 224 mean here 223. Next 240. 240 mean here 239. And here till 255. This is class A, B, C, D and E IP address. This one is for big networks, medium networks, small networks, group communications, that is nothing but multicasting, and for future use. Next I will explain what is subnetting. Name itself says subnet, that is nothing but subnetwork. Subnetting means dividing a big network into smaller networks called subnets. As for example, let us say there is college. Instead of making complete college as single network, this entire college network is divided into 4 subnetworks. IT department is one subnetwork, CSE is one subnetwork, AML is one network, and DS is one subnetwork. So dividing big network into smaller networks called subnets. There are 4 subnets. If we divide big network into smaller networks, then security and performance increases. So subnet is used to divide departments like HR, IT, accounts, etc., which will reduce network traffic and we can manage IP addresses efficiently, security increases, and IP addresses will not be wasted. These are advantages of subnet. Guys, each and every IP address has 2 parts. One is network part and next one is host part. By using network part, we can identify network, where network part will show main network, and whereas by using host part, we can identify device in the network. So host part is used to identify individual devices within the network. I'll give one example. For example, in college there is CSE department. These are various systems in CSE department. Network part is used to identify network. This is the network part. By using network part, we can identify network. As all devices belongs to single network, this network part will not change. So network part is used to identify network, and whereas by using host part, we can identify device in network. This is host part. 1, 2, 3, 4. This is host part. Host part contains unique numbers, which will not change. By using these numbers, communication is possible between devices. Guys, what subnetting will do is, subnetting will borrow some bits from host part and then it will make smaller networks. I'll give an example. Yes, for example, let us say there is a software company network which is using class C, where class C has 256 IP addresses. For example, range is from 192.168.1.0 to 192.168.1.255. As all devices belongs to same network, this network part will not change, and 0 to 255. Total there are 256 IP addresses. Out of 256 IP addresses, we will not use first IP address, that is 192.168.1.0, and similarly we will not use last IP address, that is 192.168.1.255. That is nothing but we will not give these two IP addresses to any devices. In between this, from 192.168.1.1 to 192.168.1.254. Till here, we can give IP address to various devices. That's first IP address, that is 192.168.1.0. This IP address is used to show name of the network. So we will not give this IP address to any device. And whereas last IP address, that is 192.168.1.255. This 255 number that is used for broadcasting. Broadcasting is nothing but if one device want to send data to all the devices in the network, then that computer need to use this IP address. So out of 256, 254 devices are supported. Example, there is a big network where IP address ranges from 192.168.1.0 to 192.168.1.191. So from 0 to 191. Now company want to divide this big network into 3 subnets. So one subnet is given range, that is 192.168.1.0 to 192.168.1.63. For example, this is one subnet range till here 63. Next subnet range is from 192.168.1.64 to 192.168.1.127. This second subnet range, and from 128. So 192.168.1.128 to 192.168.1.191. Guys, as we know, we will not use first IP address and last IP address. First IP address will show network name, and whereas the last IP address is used for broadcasting. So we will not use first IP address and last IP address. So usable range is from 192.168.1.1 to 192.168.1.62. And similarly this one 192.168.1.129 to 190. These are usable IP addresses. And whereas first one and last one will not use these IP addresses. This is all about subnetting. Next I will explain what is CIDR, where CIDR stands for Classless Inter-Domain Routing. Guys, by using CIDR, we can use Class A, Class B and Class C IP addresses more efficiently. So CIDR is a way to assign IP addresses in a more flexible way than a old system, Class A, B, C IP addresses. CIDR uses slash to show how many bits are used for the network part of the IP address, and the remaining bits are for devices. That is nothing but remaining devices are for host part in the network. Generally, IPv4 address is made up of 32 bits. I'll give one example. That's normally we'll give IP address like 192.168.1.1 for example. But here I'm using CIDR, so I'll include here /24. As we know, IP address contains 32 bits. So whenever we give this IP address for particular device, that is 192.168.1.1/24. So 24 mean 24 bits are used for network part, and whereas remaining 8 bits are given to host part. Network part is used to identify network, and whereas host part is used to identify device in the network. IPv4 contains 32 bits. Out of 32 bits, 26 bits are given to network part, and remaining 6 bits are used for device in the network. Next I will explain what is Internet Protocol, what is IPv4, what is IPv6, header format of IPv4 and IPv6, and then I will explain difference between IPv4 and IPv6. IP stands for Internet Protocol. It is used to send data from one computer to other computer over a network. It gives a unique address to each device, like how a house has an unique address. It decides how data packets travel from source to destination. Guys, IP address is part of TCP/IP model. In Internet, whenever sender transfer data to receiver, the data is successfully reached to receiver because of IP address. Next I will explain what is IPv4 and IPv6. Thus IPv4 stands for Internet Protocol version 4. It is 4th version of IP and it is most commonly used. Size of IPv4 address is 32 bit. This is example of IPv4 address. There are 4 numbers separated by dots. This is example 192.168.1.1. Thus each number has range. That range must be in between 0 to 255. Next I will explain what is IPv6 address. Thus normally in olden days only few people use internet. So in olden days, we used IPv4 address, as we can give IPv4 address to only billions of devices. But at present, there are more than trillions of devices in internet, and IPv4 address is already full. We cannot give IPv4 address to many devices. So in order to overcome this problem, IPv6 address is introduced, where IPv6 stands for Internet Protocol version 6, whereas IPv4 address size is 32-bit, and whereas IPv6 address size is 128-bit long, and whereas IPv4 address is separated by dots, and IPv6 address is separated by colon. This is example 2001 colon 0db8 colon so on. That's not only numbers, IPv6 address also contains alphabets. So total there are 1, 2, 3, 4, 5, 6, 7, 8. 8 set of characters separated by colon. Next I will explain difference between IPv4 and IPv6. Size of IPv4 address is 32-bit. Size of IPv6 address is 128-bit. It is written in decimal like 192.168.1.1. And whereas IPv6 is written in hexadecimal. IPv4 supports up to 4.3 billion devices. And whereas IPv6 support more than trillions of devices. That is nothing but we can assign IPv6 address to more than trillions of devices. In IPv4, header size is 20 bytes, and in IPv6, header size is 40 bytes. Guys, we can give IPv4 address to devices manually or automatically. Normally, we can give IP address manually, or DHCP server can give IP addresses automatically. And whereas in IPv6, IPv6 supports auto configuration. IPv4 has no security, and whereas IPv6 has security. IPv4 supports broadcast, and IPv6 will not support broadcast. Fragmentation means dividing our data into pieces. So in IPv4, both sender and routers will do fragmentation. And whereas in IPv6, only sender will do fragmentation. Next I will explain header format of IPv4. Thus, whenever sender transfer data to receiver, along with data, there are so many other fields included. So IPv4 header format tells complete information about data packet. These are important fields in IPv4 header along with data. These are various fields included. And the first one is version. So version is nothing but version of internet protocol, that is IPv4. So first field contains IPv4 address, and second one is header length, which tells size of complete header, and third one is type of service. Type of service tells that how packets should be treated, whether packets need to be sent fast if there is important data, and if there are less important packets, then packets need to be sent slow. So type of service tells that how packets must be treated. And fourth one is total length. Total length will say size of our packet. And next one is identification. Thus identification field contains unique ID for each packet. And next one is flags. Thus flags tells that packets can be broken or not. And next field is fragment offset. Whenever complete packet is divided into pieces, all those pieces are arranged in order with the help of fragment offset. And next one is time to live, where this field tells that how much time packet must be present in network. And next one is protocol. Protocol tells that what protocol is used in packet, whether this packet uses TCP protocol or UDP protocol. And next one is checksum. Guys, by using checksum, we can check errors in our data. And next one is source IP address and destination IP address. Whenever sender transfer data, we will include his IP address and to which computer you want to transfer data. We call that IP address as destination IP address. So it lost in IPv4 header format, source IP address and as well as destination IP address. Both are included. This is complete header format of IPv4. Next I will explain header format of IPv6. Now the first one is version. Version tells that version of IP, that is nothing but version 6. And next one is traffic class. Traffic class will show priority of packet. If packet has high priority, then packet need to be transferred immediately. If packet has low priority, packets are transferred very slow. So traffic class will show priority of packet. And next one is flow label. That's whatever the data we are sending in network, along with data, we'll give some label. As for example, let us say, I'm sending video data, which is very important. So that video data is given one label and data can be handled based on that label. And next one is payload length. Payload length is nothing but size of data. Size of data is given in this field. And next data tells that what field is coming after IPv6 address. And next one is hop limit. Thus hop is nothing but router. So hop limit tells that through how many routers data is transferred to receiver. And last one is source IP address and destination IP address. That is nothing but sender IP address and as well as receiver's IP address. Next I will explain what is multicast routing algorithm, applications of multicast routing algorithm, and then I will explain types of multicast routing algorithms. Before explaining what is multicast routing algorithm, At first you need to know what is multicast. Guess for example, in network, there are 100 computers. Out of 100 computers, sender want to send data to 50 computers at the same time. So multicast means one sender will send data to many receivers at the same time. Multicast means sending data from one sender to many selected receivers. It is used when the same message need to reach to many people at the same time, but not all. Guys, without multicasting, data will be forwarded to all computers in the network. But if sender want to send data to only selected number of computers, then we need to use multicasting. Guys, router will follow multicast routing algorithm. By using this multicast routing algorithm, data will be forwarded to many selected receivers. A multicast routing algorithm helps in sending data from one source computer to many selected receivers in a network. This algorithm creates a tree-like structure called multicast tree that connects the source and all the receivers. Multicast routing algorithm creates tree-like structure. We call this tree as multicast tree, which will connect the source and all receivers. These are applications of multicast routing algorithm. That is nothing but where we will use this multicast routing algorithm. And the first one is online live classes or webinars. As one teacher can talk to many students at the same time by using multicast routing algorithm. And second one is video conference or online meetings. One speaker can talk to many people at the same time by using multicast routing algorithm. And third one is live sports streaming. As for example, if you consider live cricket match, many people can watch live cricket match at the same time. It is happened because of multicast routing algorithm. And fourth one is stock market updates. Stock market updates are sent to many users at the same time using multicast routing algorithm. And fifth one is multiplayer online games. Yes, for example, if you consider online games, many users can play online games at the same time. It is happened because of multicast routing algorithm. Next, I will explain difference between broadcasting and multicasting. Yes, sending data to all devices in the network is known as broadcast. And whereas multicast means instead of sending data to all devices in the network, we will send data to only selected devices. This is meaning of multicast. Just in broadcast, bandwidth is wasted. Bandwidth means data wastage. Even though some devices don't want data, still data is transferred to all the devices in the network. So bandwidth is wasted. And whereas if you consider multicast, in multicast, instead of sending data to all devices in the network, data is transferred to only selected device. So here, in multicast, bandwidth is not wasted. Small networks like local area networks, they will use broadcast, and whereas large networks like internet, they will use multicast. Guys, there are various kinds of multicast routing algorithms. Our first one is flooding with reverse path forwarding. Shortly we call it as RPF. Guys, by using flooding with reverse path forwarding, one sender can send data to many receivers at the same time in network. This is how flooding with reverse path forwarding will work. Guys, for example, there is source router. Source router want to send data to multiple routers at the same time. So whenever source router transfer data, the data is reached to all its connected neighbors. So all these neighbors will receive the data. Whenever neighbors receive this data, then neighbors will check that the data is received from shortest path or not. Only if data is received from shortest path, only then these routers will transfer data to their neighbors. And similarly, again these neighbors will check whether data is received from shortest path or not. Only if data is received from shortest path, only then these neighbors will transfer data to their neighbors. Like that, this process will continue until data is successfully reached to all selected receivers. So if data is received from shortest path, neighbors will accept that message and then neighbors will send that message to their neighbors, or else they will reject that message. This is all about flooding with reverse path forwarding. Next multicast routing algorithm is DVMRP, that is Distance Vector Multicast Routing Protocol. It is first multicast routing protocol based on distance vector routing used in unicast. Guys, unicast means one sender can send data to only one receiver at the same time. And this DVMRP also uses flooding with reverse path forwarding technique in order to send messages. Reverse path forwarding means message will be accepted only if it is received from shortest path, or else message will be rejected. This is meaning of reverse path forwarding. So same example, sender will flood message to all routers. Then all routers will check whether message is received from shortest path or not. Only if all routers got message from shortest path, then message is accepted, or else router will drop that message. If router accept that message, then router will forward that message to their neighbors. If router does not got message from shortest path, router will reject that message. And next multicast algorithm is MOSPF, that is multicast open shortest path first. Guys, if you consider link state routing algorithm, In link state routing algorithm, we will use OSPF, that is Open Shortest Path First algorithm. And whereas MOSPF is extension of OSPF. Normally we will use MOSPF algorithm in network maps. In order to build shortest path, as in this technique, each and every router will share information about their links to their neighbors. So whenever sender want to send data, as each and every router know information about all their neighbors, whenever sender want to send data, based on all these links, sender side router will create shortest path in order to send data. So message will be transferred by using best path. And last technique is core based tree. Shortly we call it as CBT. As in core based tree, there is one central router called core router. So whenever any router want to send data, then this router need to contact to core router, as core router contain information about each and every router and their links. Through core router, data will be transferred to receiver. So through core router, message is sent to multiple devices at the same time. Next I will explain what is address resolution protocol. Shortly we call it as ARP. Guys, in computer networks, each and every device has two types of addresses. One is IP address and next one is MAC address. By using IP address, one device will find to other device in network, and whereas by using MAC address, data will be transferred to exact device. When a device want to send data, it knows the IP address of the receiver, but it needs MAC address. To find MAC address, device uses ARP, that is address resolution protocol. So based on IP address, ARP will find MAC address. So ARP is used to find MAC address of a device when its IP address is known. Okay, this is example. For example, device A want to send data to device B. So device A knows the IP address of device B. For example, let us say device B IP address is 192.168.0.3. So device A know IP address of device B. Now device A will send ARP request to each and every device present in the network. ARP request is nothing but device A will ask to each and every device that who is 192.168.0.3. Whenever ARP request is received to device B, now device B will give reply like I am 192.168.0.3 and my MAC address is AA colon double B colon double C colon double D, for example. So whenever device B receives ARP request, device B will give ARP response, that is nothing but device B will send MAC address to device A. As device A got both IP address and MAC address, now by using IP address and MAC address, device A will send data to device B. Guys, whenever device A received MAC address of device B, now device A will store that MAC address in memory. We call that memory as ARP cache. As device A already stored MAC address of device B, next time whenever device A want to send data, again it will not ask MAC address. Directly it will send data because MAC address is already present in ARP cache. So after finding MAC address, device saves it in memory. This memory is called ARP cache. So device will not ask again and again. Next I will explain types of ARP. And the first one is proxy ARP. In proxy ARP, a router replies to an ARP request on behalf of other device. Guys, whenever device send ARP request like asking who is 192.168.0.3, instead of device B giving reply, router which is connected to device B, this router will give reply. This is known as proxy ARP. Next type of ARP is gratuitous ARP. Shortly we call it as GARP. Guys, in this type of ARP, a device will send an ARP reply without getting any request. It is used to announce its IP address and MAC address to other devices. Guys, actually, whenever sender send ARP request, then device will give ARP reply. But in GARP, device without getting any request, automatically device will give ARP response by sending IP address and MAC address of the device. So device will send both IP address and MAC address to all devices in the network. And third type of ARP is inverse ARP. Shortly we call it as in-ARP. Because normally device will find MAC address based on IP address. But in inverse ARP, device will find IP address when MAC address is known. So it is opposite to normal ARP. And next ARP is reverse ARP. Shortly we call it as RARP. Guys, RARP is used in old devices or diskless devices. That is nothing but device don't have any storage in order to save IP addresses. So RARP is used in old devices or diskless devices. Each device knows only their MAC address. They don't know their IP address. So in RARP, there is one special server called RARP server. This RARP server is a special device that will store both IP address and as well as corresponding MAC address. So it will show both IP address and MAC address of all devices in the network. So each device will send request by using MAC address and then RARP server will give reply by giving IP address. This is all about reverse ARP. Next I will explain what is multi-purpose label switching. Shortly we call it as MPLS. Guys, by using MPLS technique in computer networks, we can send data in faster and smarter way. Guys, normally in internet, whenever device send data will move through internet by checking each and every device IP address. So each router will check IP address. Only if there is IP address match, then data will be transferred to receiver. This takes time because each router need to verify IP address again and again. So MPLS will give data a label. Label is nothing but it is like shortcut. Router just reads the label, not the full IP address. So data will move faster and easier through a network. Yes, in MPLS technique, instead of routers verifying IP address, routers will verify label. Label is like shortcut. In order to read complete IP address, it will take time. So label is like shortcut. Instead of reading complete IP address, if routers read shortcut, then data will be transferred very fast. This is example. In MPLS technique, each router will maintain table. The table contains device name, label, and IP address. For example, this computer wants to transfer data to this computer. So whenever data is transferred to this router, now this router will not verify IP address. Instead, this router will verify label. Label is shortcut. So by checking label, data is transferred to this IP address. So now this receiver will receive data. These are advantages of multi-protocol label switching. And the first one is as data will be transferred by reading label instead of IP address. So it is faster than normal IP routing. And MPLS technique can carry any type of message like voice message, video, etc. And if there is any important data, there is fixed path. Fixed path is nothing but path which will not change. So if there is any important data will be transferred through fixed path. So fixed path is given to important data like video calls, voice calls, etc. And this MPLS technique is used in big companies. Next I will explain what is hierarchical switching. Guys, hierarchical switching means arranging switches in layers to make network easy to manage. So we can add more devices easily without any issues. So adding device will be fast. Yes, normally hierarchical switching model is used in larger organizations and campuses like colleges, universities, etc. And there are three layers in hierarchical switching. And the first one is access layer. Yes, access layer is bottom layer. And this access layer can have one or more switches. And these switches are connected to end devices like computers, printers, etc. For example, if you consider your college, in your college, if you consider college lab, in lab, all computers are connected to one switch. We call that switch as access layer switch. This is diagram. For example, in our college there are 4 floors. Each floor contains computer lab. In that computer lab, each and every computer is connected to one main switch. We call that switch as access layer switch, as it is connected to end devices like computers and printers. And second layer is distribution layer. We also call it as middle layer. Distribution layer also contains one or more switches. So all switches in the access layer are connected to distribution layer switch. So this middle layer switch is used to manage traffic. Distribution layer switches will send data to core layer switch. This is example. All access layer switches are connected to distribution layer switches. There can be one or more switches in distribution layer. All access layer switches are connected to distribution layer switches. In case if there is high traffic, distribution layer switches will manage the traffic. And whereas distribution layer switches will send data to core layer switch. Core layer switch is nothing but one main switch which is connected to network. So core layer is top layer switch. This core switch is connected to network. This core switch will send data very fast between buildings and departments, and we can connect the switch to other networks. So these are 3 layers in hierarchical switching. These are advantages of hierarchical switching. First one is easy to manage. As we are not storing complete switches in single layer, we are dividing switches into multiple layers, which is very easy to manage. And second one is scalable. Yes, scalable means we can add more devices easily. And third one is fast performance. In hierarchical switching, we will divide all switches into layers. So performance will be very fast. And this design is also better. Next I will explain what is open shortest path first. OSPF. Guys, OSPF is a type of routing protocol used in computer networks. By using this protocol, routers will find best route in order to send data from one place to other place. Guys, this OSPF is a link state routing protocol, and this protocol is used in large organizations and in enterprise network. Enterprise network means big network. This is example. For example, this is big network. In this big network, this computer want to transfer data to this computer. In this route distance is 1 plus 3, that is 4. In this route distance is 10. And in this route distance is 5 plus 4, that is 9. As 4 is smallest route, now OSPF will choose this route. So now data will be transferred by using this route. So OSPF is used to find best route, that is shortest path, in order to transfer data from one device to other device. This is how OSPF will work. And the first one is routers talk to each other and exchange information about the network. Guys, in OSPF, each and every router will communicate to each other and they will exchange information. Now each router contains information about all other routers in the network. That is nothing but each router knows entire roadmap in order to transfer data. So now by using this map, each router will calculate shortest distance in order to reach to other device. In case if there is any cable break, simply router switches to other route. These are features of OSPF, and the first one is fast and works well in big networks. Guys, OSPF is used in big networks. And second one is save bandwidth. Bandwidth is nothing but it will not send any unnecessary data. And third feature is it will divide our entire network into parts, so network can be managed easily. And this OSPF will use cost system, that is nothing but low cost that equal to best path. I already said in this example, one is nothing but it is cost. When cost is less, that means better path. And in order to find shortest path, OSPF will use Dijkstra's algorithm. These are advantages of OSPF. OSPF will find new routes fastly. And second one is it is suitable for large networks. And third one is secure. No hackers can hack data. These are disadvantages. Guys, in routers, if you want to use OSPF protocol, then router needs much power and memory. This is all about OSPF. Next I will explain what is Border Gateway Protocol. Shortly we call it as BGP. Guys, BGP is also a routing protocol. That is nothing but router will follow this protocol in order to connect to different networks in the internet. So by using BGP protocol, different networks are connected to each other using internet. So big networks will talk to each other. As for example, let's say I am using Active Hypernet and my friend is using Geo. So both can communicate to each other by using BGP, that is Border Gateway Protocol. So big networks mean different internet service providers like Act, Airtel, Geo, they can communicate to each other. So BGP will tell routers which route to choose to send data between different networks. By using BGP, routers will choose best route in order to send data across the internet. Yes, as we know, internet is combination of smaller networks and as well as many larger networks. So by using BGP, device can connect to any network and can transfer data. So it will find best path in order to reach to destination. These are features of BGP. The first one is different organizations, that is nothing but different companies and different internet service providers like Active Hypernet, Geo, they can communicate each other. Even though if you are using different networks, they can communicate each other. Guys, BGP works based on routing tables. Guys, each and every router contains routing table. In that routing table, complete routing information is stored. So based on routing table, routers will transfer data to correct device. Yes, BGP is path vector protocol. That is nothing but BGP remembers the path taken. Guys, there are two types of border gateway protocols. One is external BGP and next one is internal BGP. Before explaining what is internal BGP and external BGP, at first you need to know what is autonomous systems. Group of routers under a single organization is called autonomous system. For example, let us say there is a software company. In the software company, there are so many routers. So all these routers are considered as autonomous systems. Yes, each and every autonomous system has unique number called ASA number. Yes, for example, this is autonomous system. Autonomous system contains various kinds of routers. For example, one software company is in Hyderabad and next software company is in Bangalore. These two networks will communicate to each other by using autonomous system. This is an example of external BGP. Two different networks will communicate to each other by using autonomous systems. So external BGP is used in internet to connect to different companies or different internet service providers. For example, one company is using Airtel Internet and next company is using Jio Internet. Even though both belongs to different networks, they can communicate to each other by using autonomous systems. There's not only single autonomous system, there can be many autonomous systems. So two networks will communicate each other using various autonomous systems. This is meaning of external BGP. And whereas in internal BGP, by using internal BGP, devices can communicate to each other within the organization. For example, let's say this is software company. In this software company, there is an autonomous system. In this particular organization, all devices will communicate to each other through autonomous system. This is meaning of internal BGP. In internal BGP, communication happens within the organization. All devices and routers are connected to same autonomous system. Guys, BGP will divide our network into three categories. And the first one is subnetwork. Shortly we call it as subnet. Dividing big network into smaller parts for easy management is known as subnetwork. For example, there is big network. This big network is divided into two parts. One is organization 1 and next one is organization 2. Each organization contains autonomous system and these two organizations are connected to each other. This is an example of subnetwork, dividing our big organization into two organizations. And second one is multi-connected network. Yes, network that is connected by using two or more routers is known as multi-connected network. So even if one router fails, still device can communicate by using other router. And last one is transit network. Yes, for example, there is one company. This company is connected to company router and similarly there is other company. Other company is also connected to company's router. Network which is in between this router and this router. We call this network as transit network. Whenever this company want to transfer data to this company, at first this company will send data to this router. So from router 1 through various routers, that is nothing but through transit network, data will reach to this company router. This is start point and this is end point. And whatever the network in between the starting point and ending point, we call this network as transit network. So it is a network that is used to pass data between two routers. Next I will explain what is Internet Group Management Protocol, that is IGMP. Guys, IGMP protocol is used when sender want to send data to many receivers at the same time. We also call it as multicast communication. Guys, for example, there are 100 computers in network. Out of 100 computers, sender want to send data to 50 computers. So sender will send data to 50 computers at the same time by using IGMP protocol. And this IGMP will work between host computers and routers in the same network. That is nothing but whenever one computer transfers data, the data is forwarded through various routers. And then by using IGMP protocol, router will identify that which device want to receive data and then router will send data to only those devices. Yes, IGMP is very important because without IGMP, multicast data will go to all devices in the network, which will waste bandwidth. Just for example, there are 100 devices in network, but only 50 devices want to receive data. So by using IGMP protocol, we can send data to only those 50 devices. If we don't use IGMP protocol, then we need to send data to all those 100 devices in the network. As some devices don't want data, so bandwidth will be wasted. So with IGMP, only interested devices will receive multicast data. So traffic will be reduced and performance will be improved. Guys, we'll use IGMP in live video streaming and in internet TV, video conference and online games. These are steps in IGMP. And the first step is, yes, for example, there is host computer. Host computer is nothing but computer which will transfer data. It is known as host computer. For example, let us say there are 100 receivers which want to receive data. So host computers and as well as all interested receivers, they all need to join in multicast group for communication. If all devices want to communicate each other, they need to join in multicast group. So in order to join in multicast group, all devices need to send multicast message to router. Whenever all devices send multicast message to router, now router will join all those devices in multicast group. Now sender will create multicast data which you want to send and then he will transfer data to all receivers who are present in this multicast group. Now data is successfully reached to all receivers. After receiving multicast data, sender don't have any data to send. Now sender and as well as all receivers, they will leave this multicast group by sending leave message. So whenever router receives leave messages, now router will remove those devices from multicast group. This is how communication happens in IGMP. Router will join all devices which want to communicate each other in multicast group. After sender successfully transferring data to all receivers, now all of them will leave that group by sending leave message to router. Okay, this is IGMP message format. Total there are 4 fields. One is type. Type is nothing but which type of message sender is sending to all receivers. And next field is maximum response time. How much time host computer need to wait in order to get response from all receivers. And third field is checksum. By using checksum method, errors are identified in our message. And fourth field is group address. This multicast group contains IP address. We call that IP address as group address. So whenever sender transfer data in multicast group, he will also include this group address. Next I will explain what is mobile IP, where IP stands for Internet Protocol. Guys, mobile IP is nothing but it is a protocol. By using this protocol, devices like mobile phones and laptops, they can communicate to different networks without changing IP address. Guys, even though if you move our mobile to various locations, still we can access internet. It is because of mobile IP. Guys, normally if you move our device to new network, then IP address will change. But if you consider some applications like video calling and online games, if we change IP address, these applications will not work. So applications like video calls and online games, they need fixed IP address in order to work properly. So by using mobile IP protocol, we can solve this problem by keeping our IP address fixed even if we move to different networks. Guys, there are four main components in mobile IP. Device like phone or laptop, which is moving, we call it as mobile node. Guys, normally in our home, we will connect our mobile to router in order to access internet. So home agent is nothing but router which is present in our home. We call it as home agent. For example, from my home, I will move to some other place. And in order to access internet in that place, I need to connect to other router. So router in new network is known as foreign agent. So home agent means router which is present in our home. And foreign agent means whenever we move our mobile to some other place, if we connect to some other router in order to access internet, we call that router as foreign agent. Guys, care of address means a temporary IP address which is given to our mobile in foreign network. We call the temporary IP address as care of address. Guys, for example, guys, corresponding node means node which want to transfer data to device which is present in home network. We call the device as corresponding node. For example, one mobile is present in home network and there is other mobile which want to send data to device which is present in home network. So we call this node as corresponding node. Guys, whenever this mobile transfer data, it will include IP address of receiver. That is nothing but this device will include IP address of this device. But whenever this device is sending data, actually this mobile is moved to this network. Now this mobile is not present in this network. Now this mobile is moved to foreign network. So now this mobile is in some other place, that is in foreign network. But this corresponding node don't know that this mobile is moved to foreign network. So whenever this mobile transfer data, at first data is sent to router. By using this router through internet, data will be reached to this router. Now this router will identify that mobile is not present in home network. So now whenever home agent receive data, it will add other field. That other field is known as care of address. That is nothing but where device is present, it will add that address. And this care of address belongs to foreign network. Now data will be transferred to foreign network. Now whenever this mobile receive data, this mobile will remove care of address and then this mobile reads the data. So care of address is nothing but temporary address given to mobile when mobile moves to foreign network. And this address is given by router. So whenever mobile is not present in that network, by using care of address, data will be transferred to mobile which is present in other network.